Yun po, magandang araw. Magandang araw po sa lahat. So, hintay lang po tayo saglit. May onting delay lang po kasi nagkaroon po tayo ng problem, konting technical difficulty sa side po nung ah, lecturer. So, habang naghihintay po tayo, basahin lang po natin yung slideshow for the webinar etiquette and other informations about the lecturers and the whole SINSM.
Okay. So for the general mathematics course, I think this includes
Hello, good morning po. Ayan, bago po tayo sige, so bago po tayo mag-start sa lecture, ipaalala ko lang po yung mga dapat po nating ma-observe during the lecture. So, pakipatay na lang po yung microphone and webcam po natin during the talk. Tapos, pag meron po tayong mga tanong, mag-post na lang po tayo sa chat. Okay? Kolektahin na lang po siya ng moderators, then itatanong na lang po siya after. So towards the end of the last presenter scheduled for the day, the link for the evaluation form will be posted and certificates will be awarded to attendees who attended at least 75% of all talks in the workshop. Okay? And so, dagdag reminder, yung certificate tsaka eval form po para kay Sir Anthony, yung speaker natin ngayon, ay i-post na lang yung link this afternoon. Okay? So, welcome po ulit sa second day ng SINSM. So, our lecturer for today is an assistant professor of mathematics of the Department of Mathematics and Computer Science. So, a few words about our lecturer. During his undergraduate years as a ABS Math student, he was a consistent college or university scholar, that is equivalent to deans and president's lister. And consequently, in 2014, he graduated magna cum laude with a GWA of 1.35. So in 2018, he finished his master's degree in math with a GWA of flat 1 and is currently taking up his PhD in same university. His current publication includes the title Delay-Induced Stability Switches in an SIRS Epidemic Model with Saturated Incidence Rate and Temporary Immunity, published in the Journal of Physics. So without further ado, let us all welcome Prof. Anthony Passion.
Thank you very much for that kind introduction, Sir Joy. Let me just share my screen. Magandang umaga po sa ating lahat. Sana po ay nakikita natin ang share screen ko po. So, at naririnig niyo po ako ng malinaw at malakas. So the title of my talk for this morning session would be on the K-12 Pre-Calculus course, Mnemonics in Trigonometry. So I will teach you some teaching strategies that I know, some memory devices in trigonometry, because as you will know, trigonometry is a branch of mathematics wherein ang daming kailangang malaman, di ba? You have trigonometric function values for many angles. You have trigonometric identities. If you will memorize them all, then it will lead to nowhere. So in this course, let us see if kung makakatulong itong mga mnemonics or memory devices in trigonometry. All right, so first question, why study trigonometry? So I have a comic strip here from Calvin and Hobbes by Bill Watterson. So let us just read. Miss Wormwood, I have a question about this math lesson. Sabi ni Miss Wormwood, yes. Given that sooner or later we're all just going to die, what's the point of learning about integers, or let us say trigonometry? And ano yung ginawa ng teacher? She just ignored Calvin. So sabi niya, turn to page 83 class. And then sabi na lang ni Calvin, nobody likes us big picture people. So as a mathematics educator, I think na-experience na natin itong question na ito siguro yung pinakamahirap na pwedeng itanong sa atin ng isang student. So, saan ko pa magagamit yung mga tinuturo mo, sir? Something like that, di ba? Well, of course, there's a problem here. Kasi una pa lang, hindi na sinusundan ni Calvin yung, as a mathematician, yung step-by-step process, right? Kasi nag-iisip agad siya ng death, bata pa lang siya. Paano na lang yung mga subsequent years nalalaki siya. Okay, so as an educator, how do we tackle questions like this or philosophical questions? Asan ko ba magagamit yung mga tinuturo mo, sir? Or what's the use of trigonometry? Sometimes nagpapanik na lang tayo, di ba? Na kung ano-anong sinasabi na nating applications, basta magagamit mo yan kapag naging engineer ka or kapag naging mathematician ka. But of course, in my case, the best way to tackle questions like this would be honesty na lang. Let us just be honest. Sabihin natin na I'm not sure kung magagamit mo siya in the future. I'm not God. Hindi ko alam kung ano yung future mo, kung magiging engineer ka ba, kung magiging mathematician ka. But I'm sure that later on, you will need this. Because it will appear later in calculus. So if you are a K-12 student, grade 11 STEM track, then pinag-aaralan mo to because you will need later in calculus, because you will also take calculus course, right? Yun muna yung isipin mo. Think of the present before thinking of the future, something like that. It will come to you later on kapag naging adult na yung bata kung makakatulong ba or hindi. Kung nakatulong yung tinuturo ko sa'yo, then let us be thankful. Otherwise, then let's move on. Okay? So I did not prepare an outline of my talk, so I will just dwell into it. So this is the textbook definition of the 6 trigonometric functions. So if theta is an angle in standard position, pxy is any point other than the origin. So I have this figure here. So sabi dito, an angle is in standard position if it's drawn in the xy plane with its vertex at the origin. So as you can see here, the vertex ito is at the origin. Okay, of theta, and r is equal to the square root of x squared plus y squared. So this came from our well-known Pythagorean theorem. Then we have the 6 trigonometric functions using this triangle here. Sine theta is y over r, cosine theta is x over r, tangent theta y over x. Of course, the denominator should not be equal to 0. Cosecant theta is equal to r over y, secant theta r over x, and then cotangent theta x over y. Okay, so this is the textbook definition. If you have a triangle like this, ito daw yung definition ng mga 6 trigonometric functions. But we do not teach it like that because it's hard to memorize that. So ano ulit yung una nating mnemonics in trigonometry? Of course, we use the SOHCAHTOA. All right, so if this is your angle theta here, so this side, opposite your angle theta, we call this the opposite side. The adjacent side, of course, yung katabi niya, and of course, the longest side of a right triangle, we call it the hypotenuse. And then, it turns out that trigonometric ratios can be written as follows. So, kaya nga, tinawag na SOHCAHTOA. So, sine theta is opposite over hypotenuse. Ito yan, yung SOH. Cosine theta is adjacent over hypotenuse. So, and then tangent theta is opposite over adjacent. And as you can see here, I have cosecant theta, secant theta, and cotangent theta. Bakit SOHCAHTOA lang yung andito? Bakit hindi mo na kailangang tandaan itong mga cosecant, secant, cotangent theta? Because we have what we call the reciprocal identities, right? As you can see from this equation, itong cosecant theta, pwede ko siyang isulat na 1 all over sine theta. Similarly, itong secant theta, I can write this as 1 all over cosine theta. And then cotangent theta would be 1 all over tangent theta, right? So I will tell you later on that we call this reciprocal identity. So kapag alam mo na pala yung value ng sine theta, cosine theta, and then tangent theta, parang alam mo na rin yung cosecant theta, secant theta, and cotangent theta. You will just use this because 1 all over sine theta, 1 all over cosine theta, 1 all over tangent theta. And madali lang itong tandaan because the reciprocal of sine is cosecant. Palaging magkaiba yung first letter nila. For example, S, dito ay C, S, T, tapos C. Right? Yun yung basehan mo. Kung nakalimutan, ano na ulit yung reciprocal ng cosine theta? Alam ko cosecant or secant eh. Kasi yung tangent, madali lang naman tandaan, di ba? Yung reciprocal niya, yung cotangent, kasi andun yung word na tangent. Okay, you just take the first letter. Okay, basta tandaan mo, yung reciprocal niya ay dapat magkaiba yung letra. So, in the case of cosine theta, the reciprocal would be a secant theta. So, that's the first. Okay, so how will we get the trigonometric function of special angles? So special angles will include, from 0 to 90 degrees would be 0 degree, 30 degrees, 45 degrees, 60 degrees, and 90 degrees, right? Why do we call them special angles? Because we can actually compute the 6 trigonometric function values of these special angles exactly. So may paraan tayo para ma-compute. Of course, we will not do the derivation here. But the question would be, ito di ba yung palaging tanong ng mga student, ano na ulit yung cosine 0? Ang alam ko 0 or 1 eh, pero alin sa dalawa? Di ba? Usually alam nilang 0 or 1. What again is sine 30 degrees? Ang alam ko, 1/2 yan or square root of 3/2 because they occur in pairs, right? Pero hindi na nila alam kung saan sa dalawang yan. So in this case, I will teach you what we call the hand technique para mas matandaan natin. Okay? Or the hand trick. So paano ba gumagana itong hand trick? Let me... Okay. Can you see my share screen, yung isa? So you can see a hand there. It's left hand actually. Pwede mong gamitin yung right hand mo, but I will use my left hand because I use my right hand to count. Okay, so the idea here is itong mga 5 daliri natin, they represent the 5 special angles. So you start from your pinky going to your thumb, you write, ito yung 0 degrees, 30 degrees, tapos 45 degrees, 60 degrees, and then 90 degrees. The idea here is, kasi kapag kunwari nakaganyan yung kamay mo, yan, you can actually have a right triangle here, di ba? Yan. Kaya ganyan yung numbering natin. Okay, so parang itong mga daliri natin yung mga special angles. So 0, 30, 45, 60, 90. Okay? You write below your hand, below your pinky would be the word sine. Okay, this will be helpful later on. And then above would be cosine. Using these fingers, we can actually have a mnemonic device in remembering the trigonometric values of these special angles. Ganito yung idea. So the formula is always, for example, sine. Magbibilang ka lang ng square root of number of fingers all over 2. Similarly, ganun na rin yung formula for cosine. Number of fingers all over 2, square root. Lahat may square root niyan. Okay, so dito, sine, bakit nagsulat ka ng sine dyan? Because you will count the number of fingers below. Thus, cosine fingers above. Okay, so ganito yung idea. For example, you want to compute sine 30 degrees. Okay, so the idea here is you fold, yung 30 degrees kasi would be your ring finger, so you fold it like this. Ganyan, so mamarkahan ko na lang dito. Fold nyo lang, huwag nyong putulin. Okay, and then sabi dito, you just count the number of fingers below. So below this 30 degrees, ilan ba yung finger na meron ka? In this case, you just have 1. Ito. Yan. So number of fingers all over 2, you have square root of, yung gamitin natin. You have square root number of fingers below, kung ano yung na-fold mo, which is this, so 1. Square root of 1. Bakit bumalik? All over 2, and this is just 1/2. Ganun lang kasimple, magbibilang ka lang for sine. For example, you want to compute cosine 60 degrees or cosine 30 degrees. It's the same technique, so you just count. For cosine, you count the numbers above, kung ano yung finold mo. So in this case, yung 60 ay andito. 30 ay andito pa rin. Ilan yung fingers at na above 30 degrees? So 30 degrees, you count 1, 2, 3. So you have square root of 3 all over 2. That's it. Yan na yung cosine 30 degrees. And you can do this for all. 0, 30, 45, 60. Ganun lang yung mnemonic devices natin. And the formula is still the same. Square root number of fingers. If it's sine, you count the numbers. If it's sine, you count the number of fingers underneath. If it's cosine, you count the numbers above. And mag-work to kahit ano. For example, you have a sine 0. What is sine 0 in this case? In this case, sine 0 is sine 0 degrees. I-fold mo to. Yan. Kapag naka-fold na yung pinky mo, ilan na lang yung daliri mo sa baba? Wala na, di ba? So you have square root of 0 all over 2, and this is a 0. O cosine 0 degrees. You fold, how many fingers you can count? 1, 2, above. Ito yung ayan yung naka-fold. So you count 1, 2, 3, 4. So you have square root of 4 all over 2. And kapag sinimplify natin, this is 2 over 2, you get 1. This works for any. So hindi mo na makakalimutan. For example, sine 45. Last example. Yung if-fold mo in this case would be yung 45 kasi yung middle finger mo. So ilan yung nasa baba for sine? 1 and 2. 1, 2. So you have a square root of 2 over 2. Similarly, for cosine 45, ganun rin kasi dalawa, di ba? Kasi middle finger. So you have square root of 2 over 2. Okay, so this is the hand trick for sine and cosine. Actually, this actually works for tangent also, but we have a different formula. For tangent, ganito yung idea. Okay, so for tangent, the formula is ganun ulit, square root of number of fingers all over square root of number of fingers. So, paano naman ito? Ganito yung idea para mas madaling bilangin. All right, so for example, I will square root of fingers. Let me just go back to this. Kunwari gusto kong malaman yung tangent 30 degrees. So kapag i-fold ko tangent 30 degrees, yung ring finger, di ba, yung ma-fold ganito. Something like that. Pero yung nakaharap yung hand ko sa akin. Okay. So the idea here is isasap mo yung kamay mo bago ka magbilang. Okay? Nakaganyan na. Ang idea here is because of the word tan. Yung tan, itong palad natin ay mas madalas, mas maputi ito kaysa sa backhand natin, di ba? Mas maitim to, kaya tan. Kaya yung idea ay mas tan ito. Something like that. So you fold. So nakaganyan ka una, iganyan mo bago ka magbilang. So the idea here is, square root of number of fingers, you just count above. Kasi naka-fold na, so 1. So you have square root of 1 all over yung nasa baba naman. 1, 2, and 3. So square root of 3. Okay? So that's the idea for tangent. Fino-fold ko kasi may ako dito, mahirap i-fold kasi nasa picture. But if we will use this figure, kapag ganito, kung hindi mo na i-fold, the formula would be fingers below, tapos fingers above kapag hindi mo i-fold. So for example, what is tangent 60 degrees? So ganun ulit. So 60 degrees is this. Bilangin mo lang, square root of number below. So 1, 2, and 3. So I have square root of 3 all over. Fingers above, 1 lang. Yung thumb mo lang. And you have square root of 3 all over square root of 1. This is square root of 3. Okay? Pero ako, mas madali kasi kapag, syempre kapag wala namang, hindi ka naman na mag-drawing, gagamitin mo na yung kamay mo, di ba? So, ikukon ko na lang, saka ako magbibilang. Square root over square root. Okay? And this works for any angles here. Mag-work siya for 0 and 90 degrees. Okay? So, we call this the hand technique. Okay. We also have another technique for remembering the trigonometric function values of these special angles. We call it the table technique naman. Ito, minsan, mas maganda daw itong gamitin kaysa sa hand technique or the hand trick. The idea here is, ang sabi nila, kailangan mo lang namang tandaan daw yung trigonometric function values ng sine. After daw niyan, kapag alam mo na rin yung cosine, alam mo na rin daw yung tangent. And so on. Mag-follow daw. So for example, 0 degrees, 30 degrees, 45 degrees. So just create a table. theta 45 degrees, 60 degrees, and then 90 degrees. So the idea here is, yung sine theta, lahat yan ay may over 2. Yan, over 2. And then lahat daw yan may square root sa numerator. And the pattern goes like this. You fill up the table counting from 0 to 4. So n equals 0, 1, 2, 3, 4. Yan. So 0, magbilang ka lang to 1, 2, 3, 4. Yan na daw yung mga trigonometric function values ng sine theta. And this is true because kapag sinimplify ko, ito ay 0. This is 1/2. This is square root of 2 over 2. This is square root of 3 over 2. And this is 1. Yan. Bakit daw, kapag alam mo na daw yung sine theta ng mga yan, alam mo na rin yung cosine theta. Ganito yung idea because yung kapartner ng 0 palagi, kapag sine theta ay 0, automatic 1 na yan, di ba? See, parang partner sila. Yung partner ng 1/2 would be square root of 3 over 2. Ito ay, partner niya ay sarili niya. Ito 1/2 and this is 0. You can also use the table trick, but in this case, for cosine theta, for example, this is 0, 30, 45, 60, and then 90 degrees. The trick here is it's backwards. So 4, 3, 2, 1 naman. 4, 3, 2, 1, 0. So you have square root of something over 2, 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 square root of something over 2. You count 4, 3, 2, 1, 0. You're done. And that's it. It's the pattern. So this is the table technique. And kapag alam mo na daw yung sine tapos cosine, gagamitin na lang daw nila yung tangent theta is equal to sine theta all over cosine theta. So this is a quotient identity na i-introduce ko later on. That's it. So it's up to you kung anong technique na gagamitin mo. Basta ang importante, it's the starting of trigonometry. Kapag hindi alam ng mga students natin mag-compute ng mga trigonometric function values ng special angles, maybe later on, they will have a difficulty talaga. Right? Memorization doesn't work here kasi magkakamukha yung mga yan. Sabi ko nga sa iyo, yung mga question na ano na ulit yung cosine 0, ang alam ko, either 0 or 1 yan eh. So hulaan ko na nga lang. Ang hula ko ay parang mas maganda yung 1. Is it tama? Tama ba yan or hindi? Of course, sinulaan nyo lang. But if you know the hand trick or the table trick, then it's good. You're good to go. Okay? So let me go back. And that's how you compute the trigonometric values of special angles. Paano naman kapag hindi na special angles na between 0 and 90? So the next question we would like to answer would be how to determine the values of the trigonometric functions of angles greater than 90 degrees or less than 0. Kasi di ba may mga negative tayong angles, right? Kapag yung rotation ay hindi counterclockwise but clockwise. So paano natin i-compute ng mga yan? So let us do this step by step. The first concept we need would be the concept of reference angle. So let theta be an angle in standard position. Its reference angle is the angle theta prime formed by the terminal side of theta and the horizontal axis. So yung x-axis lang. So we have this following figure here. Sorry. So for example, kapag ito yung angle theta mo, so nasa quadrant 2 yung theta, yung reference angle niya would be, ito kasi yung terminal side ng theta. The reference angle is formed by the terminal side and the horizontal axis. The horizontal axis is just the x-axis. So ito lang yan. So your reference angle is this. Yan yung reference angle niya. Okay? Kapag yung theta mo ay nasa quadrant 3, so ito yung reference angle mo. And if your reference angle, if your theta is in quadrant 4, so you have this, your reference angle is this. And what do you notice about the reference angle? So the reference angle most of the time is, this is an acute angle, right? So it is just it's between 0 degrees to 90 degrees. Okay? And napaka-importante niya kasi may technique na tayo para mag-compute ng mga special angles ng mga 0, 30, 45, 60, 90. Okay? So in this case, what is your formula for theta prime here kapag andito yung theta mo? So let me write. Okay. So in this case, your theta prime, this is equal to, you just measure. Ito kasi 0, 90, 180. So ito ay 180 degrees. So kung gusto mong sukatin ito, i-subtract mo lang, right? So you have 180 degrees minus theta, kung ano man yung theta na yan. Paano naman kapag nasa quadrant 3 siya? Okay? So alam mo na 180 yan. So para masukat ko ito, kailangan kong isubtract yung theta dito sa 180 na yan. So in this case, your reference angle is computed as theta minus 180 degrees. Paano naman kapag nasa quadrant 4 na siya? How will you compute the reference angle? So alam mo kasi yung buong ikot na yan would be 360 degrees, right? Because it's a full rotation or yeah. So kapag gusto mong sukatin ito, you have 360 minus this angle here. So theta prime here is 360 minus theta. Sir, kailangan bang i-memorize yan? It's not. Hindi mo kailangan i-memorize ito kasi if you want to compute a reference angle, the best idea is to draw kung saan siyang quadrant. Right? So let me give an example here. So example. Find the reference angle. Yan. So let me go back to this. Sinulat ko na siya. So find the reference angle at theta prime when theta is 145 degrees, 300 degrees. So the idea here is, the best idea to solve this problem is to draw. So for example, for letter A, I have theta is 145 degrees. So hanapin mo muna kung saan si theta, sa anong quadrant siya. You can do this by setting 0 degrees. Ito ay 90 degrees. This is 180 degrees. And then 170 ay 270 degrees. All right. So saan ngayon si theta natin? If it's 145, you know that it is greater than 90, but it is less than 180. So alam mo, nandito si 145. Let us say yan si theta. Okay? So your reference angle is this. Yan. So ito yung reference angle mo. And how do you compute this? You just manipulate. Paano ko susukatin ito? Alam kong 180 yung buong yan. So para makuha ko lang ito, isusubtract ko lang. So your theta prime here in this case, or your reference angle is 180 degrees minus 145 degrees. And I believe this is 35 degrees. So hindi pala siya special angle. Sayang. So 180 minus 145, 35 degrees. And you can do this for letter B also. You just draw. This is the easiest. So I have left. So 0 degrees, 90 degrees, 270 degrees para my guide. 270 mali. 180 degrees. And then you have 270 here. Tapos, ganun ulit. Hanapin mo. Ay, saan ba si 300 degrees? Dito siya, di ba? So, para ma-compute mo yung reference angle, and that's, you just follow. Alam mo kasi na buong yan ay 360 minus 300 degrees. You will get 60 degrees. So, ito naman yung reference angle. Okay. So, in getting the reference angle, the easiest way or the technique would be to draw it and then you analyze it. Okay lang naman mag-memorize, but sometimes, mas magandang i-drawing mo na lang kung saan siya saka ka mag-analyze. Okay? A visual aid in trigonometry is very helpful. Okay. The next one would be how to determine the signs of the trigonometric functions in the 4 quadrants. Okay? Ganito kasi yung idea. Kunwari, meron kang, for example, your theta is here. Yan yung theta mo. Yung sin theta ba niya, is it positive or negative? Ano yung sign ng sin theta ko? Yung cosine theta ba niya, is it negative or positive? Something like that. Or baka naman zero. Hindi mo kailangang isipin kung positive siya or negative. So the technique here would be, I call this, paano natin malalaman? So the mnemonic device, in order to determine the sign of the trigonometric functions in the four quadrants would be, we call it the asymptotic technique. Okay? Yung A dyan stands for all. Yung sine, tangent, and cosine. So in order to use this technique, you need to draw the following. So meron kang four quadrants. So 1, 2, 3, 4. And the asymptotic technique goes counterclockwise. So isulat mo sa quadrant 1 all. Sa quadrant 2 ay sine or S. Tapos dito ay tangent and this is cosine. How do you use this figure here? The idea here is, kapag si theta ay nasa quadrant 1, kaya all yung nakalagay dyan, lahat ng trigonometric function values of that angle is positive. Positive lahat. Kapag si theta ay nasa quadrant 2, yung positive lang ay yung sine at yung reciprocal niya, no, na ulit yung reciprocal ng sine, cosecant, di ba? Starts with the different letters. Yung iba, negative na. Dito, ang positive lang ay tangent, tapos yung reciprocal niya, which is cotangent, dito naman ay cosine lang. So in summary, you have the following. So all, positive, negative, none. Sabi ko dito, yung positive lang ay yung sine, tas reciprocal niya, which is cosecant. You just remember the positive kasi kung hindi positive, you have no choice but to say it is negative. Dalawa lang naman yung choices natin. For tangent, you have tangent and cotangent, quadrant 3. And quadrant 4, cosine and secant lang. You can remember this using the, yan. All students take calculus, but other students do not remember this. Mas natatandaan nila yung ito. Yung all science teachers are crazy. Kasi kapag may gumagamit ka ng mga weird, di ba? Ng mga weird na statements, mas natatandaan nila. Right? So you can remember the asymptotic technique either by remembering all students take calculus, so ASTC, or all science teachers are crazy. Okay? This mnemonic device came from Pre-Calculus by Larson. This one came from Additional Mathematics by Heng, Chen, and Talbert. Marami pa actually kasi pwede kang makabuo ng marami sa A, S, T, and C. So, example, determine the quadrant containing angle theta. So, saan daw si theta na quadrant kapag given sin theta is negative because it's less than 0, tangent theta is greater than 0. So, we use this technique. Madali lang naman siyang gamitin. All right. So, determine the quadrant containing angle theta. So, first, let us draw our sin tan cos technique. Sin tan cos. Yan, ganyan lang. Counterclockwise. Madali lang tandaan. Okay? So, letter A. Saan daw si sin theta is less than 0? So, sin theta is negative. Ibig sabihin yan. Tangent theta is greater than 0. So, ibig sabihin si tangent ay positive. So, unahin natin. Saang quadrant si sin theta ay negative? Okay, dito, all, hindi siya negative dyan. Dito, positive siya. Kasi positive. So, it's either dito or dito, di ba? So, pwede andito si, yan, lagyan natin ng marka. Saka nyo burahin. So, sin theta is negative either here or here. But tangent theta is greater than 0. So, parang process of elimination siya. Using this here, na-eliminate na natin yung quadrant 1 and 2. How about tangent theta is greater than 0? Dito lang siya positive because andito siya. Diba? Negative siya dito. So, uy, dali lang pala. Theta is in quadrant 3. Yan na. Okay? Yan, positive kasi, so hindi pwede dito kasi negative si tangent dito. Sabi ko ang positive lang dito ay yung cosine tapos yung reciprocal niya. You can do the same for letter B. Cosine theta is greater than 0. And sine theta is less than 0. So, ganun ulit yung technique. Sine theta is positive. So, saan positive si cosine? Positive siya dito, positive rin siya dyan. So, wala na yan, out na yan. So, ito lang yung choice mo, either dyan or dito. Pero, using your second inequality, sine theta is negative. So, negative. Sa dalawang choices mo, saan dyan negative? O dito, lahat positive, so hindi na yan. Dito na lang. So, in this case, theta is in quadrant 4. Ganun lang kasimple. So, kapag yung theta ay andito, ang positive, lahat ng trigonometric function values niya ay positive. Kapag yung theta ay andito, quadrant 2, yung positive lang ay yung sine at yung reciprocal niya. Kapag theta is in quadrant 3, ang positive lang ay tangent and yung reciprocal niya. And kapag yung theta ay nasa quadrant 4, ang positive lang ay yung cosine and then yung reciprocal niya. So this is the asymptote cos technique. So the idea of the two techniques here, the reference angle and the asymptote cos technique, because it helps us actually to evaluate trigonometric functions of any angle. So to find the value of a trigonometric function of any angle theta, first determine the value for the associated reference angle. Kayang-kaya natin to because kapag acute angle na siya, kapag tapos special angle, we know already using our hand trick. The next one would be depending on the quadrant in which theta lies, affix the appropriate sign to the value. Kaya importante rin yung asymptote cos technique because it determines the sign of the trigonometric function value. Okay? So, yun lang, ganun lang kasimple. Determine the value for the associated reference angle theta prime. Depending on the quadrant in which theta lies, affix the appropriate sign to the value. So let us discuss the following examples. Sine 135 degrees. Okay, so let us draw para lang may guide ako. So I have 0 degrees, 90 degrees. Okay, 135 degrees, so ang quadrant siya, it is quadrant 2. Yan. Yan yung 135 degrees. So how will we compute the reference angle? So una, ano yung reference angle nito? So sine 135 degrees would be, okay? Yung reference angle niya is, ito lang, di ba? 180 minus 135. So it is 45. So equal lang pala ito sa sine 45 degrees. So ito yung reference. So markahan natin. This is your reference angle. Okay. Step number 2, affix the appropriate sign. Mag-affix muna tayo ng appropriate sign. Theta is in quadrant 2. So if I will mark this as A, S, T, C. So asymptote cos technique. Si sine dito, kasi andyan siya, so positive dito. Di ba? Kasi andyan yung theta natin eh. So yung sine nito would be plus. Of course, hindi na kailangan kompletuhin later on, but so this is your sine. And using your hand trick, ano yung sine 45 degrees? Alam na natin to, yung table trick, table or hand trick, just fold, dito yung sine, sine, count the numbers below, so 1, 2, square root of 2 over 2. And you do this for the rest also. How about letter B? cosine 240 degrees? Okay. Ito na lang yung gamitin natin. Hindi na ako mag-drawing. Saan si 240? Alam nyo na andito sa quadrant 3 yung 240. Bakit andyan siya? Kasi it is greater than 180 to 70. Ngayon, paano natin i-compute yung reference angle? It is 240 minus 180 kasi andito siya, di ba? So, 240 minus 180 would be 60. Affix the appropriate sign. Since andito si theta mo, positive ba siya or negative? Yung positive lang ay tangent at cotangent. Ang pinag-uusapan natin ay cosine, so it is negative. Ano yung cosine 60 degrees? 100. 60 ay ito, yung 0, 30, 45 ay yung index finger pala. Ano yung bibilangin natin? Since cosine above, so 1. So this is square root of 1 over 2 using the 100. 1/2 siya. Ay, yung negative sign pala. You affix the negative sign. And you can also do letter C and tangent 390 degrees using the same technique. And that's how you determine for example, 300. Let us just do this quick. Sine 300, alam natin na quadrant 4. So, si sine ba ay positive dito or negative? Okay. Cosine lang ang positive. So, sine is negative. Alam ko ng negative yan. Ano yung reference angle ng 300? 360 minus 300. Alam kong sine 60. Sine 60 degrees. Ano yung sine 60 degrees? Using any trick you want, this is negative square root of 3 all over 2. Tangent 390 degrees. Ganun ulit, mag-work ulit. Nasa quadrant, sumobra. So saan quadrant na ito? This is 360. So sumobra ka ng 30 degrees. So nasa quadrant 1 ka na. So tangent there is positive. So parang ito ay equal sa tangent 30 degrees. Positive siya kasi all trigonometric function values here is positive. So what is tangent 30 degrees? 100. 30 tas balik ta rin magbilang. Square root of 1 all over 1, 2, 3. Square root of 3. 1 all over square root of 3. You can rationalize if you want, but this is an exact value, so tama na siya. Okay. And that's how you compute the trigonometric function values of angles greater than 90 degrees. Di ba? Step by step, dali lang. Hindi mo kailangan memorize lahat. Kapag alam mo yung process, tas may mga mnemonic devices ka, ang dali pa lang mag-compute ng mga ganito Magiging favorite na nila yan. How about negative angles? So what's the technique here? How to determine the values of the trigonometric functions of angles less than 0 degrees? Okay? Or negative angles. Kasi nagkakaroon tayo ng negative angles kapag measure mo siya, instead of clockwise, you can measure it counterclockwise. For example, kapag meron akong angle dyan, meron kang theta, pero pwede mo rin kasing sukatin ito pag ganyan, di ba? So may parang another theta 1 ka, theta 2. Okay? Yung theta 2, since measure mo siya counterclockwise, positive siya dyan. Dito naman, since you measured it clockwise, negative siya dito. Okay? Kaya tayo nagkakaroon ng negative angles. So, what's the technique here? Paano? You can also use the reference technique I mentioned earlier. Pwede namang may reference angle Hindi hanapin mo na lang yung positive sign niya, di ba? Kunwari negative 30 degrees. Ano yung positive na equivalent niya? Okay? But actually in this case, I'm using this technique. It's easier. We call this D. Yan. Okay, I call this the 7 technique or Kevin technique if you want. Okay, yung cos dyan, kasi yung C, sa cosine siya kasi may mga trigonometric function values, di ba, na cotangent and cosecant. Pero ito ay COS even, so cos7 technique if you want. So the idea here is C tas slash even. So ibig sabihin yung cosine ay even. Kaya ganyan siya. Okay? So this technique tells us that cosine and yung reciprocal niya lang, which is secant, are even functions, the rest are odd functions. Yung rest ay odd functions na. Ibig sabihin nito, kapag alam mo yung cosine is even, tas yung the rest ay odd, madali na lang because as an even function, cosine of negative theta is just equal to cosine theta. Yan yung ibig sabihin ng even. Okay? So the quantity of cosine negative theta is just cosine theta. Secant negative theta is secant theta. Tas kapag odd functions naman siya, so something like this. So sine of negative theta is equal to negative sine theta. So ganun lang. Ito lang yung tatandaan mo. Cos7 technique. Yung cosine, yung reciprocal niya even, the rest odd functions na sila. So ang dali lang nito kasi parang paano mo i-compute yung sine negative theta? Ay, parang i-factor out ko lang pala yung negative. Pero syempre hindi yun, hindi factor out yung term. Parang na-factor out mo siya kasi this is an odd function. Okay? So negative sine theta. Ang kagandahan nito, yung negative nawala na sa theta, di ba? Ang dami na nating techniques para i-compute yan. Ay, dyan na lang pala yung negative. Ang saya na. Ang saya na ng buhay natin because of this technique. Hindi ka na kailangan mag-reference angle. Sa positive ka na lang magre-reference angle. For example, what is sine negative 150 degrees? What is cosine negative evaluating negative. Yan. So, what is this? So, what is sine 150? Mali ata yung nailista ko. This is negative. So, yan. Even technique. Yung cosine, tas yung reciprocal niya lang, yung even functions. The rest are odd functions. So, sine negative 150 degrees. Uy, equal lang pala ito sa negative sine 150 degrees. Tapos i-apply mo na yung mga tinuro kong technique kanina, paano i-compute yung sine 150. Ano yung reference angle niya? Saang quadrant located itong 150? You do the manipulation. Okay? And you can easily do this. This is negative of sine 30 degrees. I think the reference angle of 150 is 30. Tama ba? 180 minus 150. Okay. So 150 is in quadrant 2. So positive yung sign doon using your asymptote cos technique. And I think this is negative 1/2. Just correct me if I'm wrong. Cosine negative 90 degrees. Uy, even ito. Because of this Kevin technique or 7 technique, tawagin nyo na lang siya kung ano yung gusto nyo itawag. Uy, tanggalin ko lang pala yung negative. So this is just cosine 90 degrees. You use your hand trick, cosine 90 degrees. If fold ko, magbibilang ako ng numbers above my thumb. Wala. So you have square root of 0 all over 2. This is now 0. Ay, tama ba? Yes. And that's it. So that's how you compute trigonometric function values of any angles. So if it's special angles, you use the hand trick. Kapag sumobra na, you use the technique of sines, the asymptote cos technique, and the reference angle technique. Kapag negative, you use the 7 technique. And that's it. Okay, if you have questions, feel free po to interrupt me. Okay, thank you. Hindi pa tapos pala. And trigonometric functions. So applications of trigonometry. So in ancient times, it was used in surveying, navigation, and astronomy to find relationships between the lengths of sides of triangles and measurement of angles. So in this case, ang trigonometry, pinag-aralan lang yan because of triangles. okay, and measurement of angles. So in this case, trigonometric functions have angle measurement as their domain. So kaya nga, yung mga pinag-uusapan pa lang natin dito, puro angles. So 150 degrees, 90 degrees. Okay. But right now, in modern times, there are applications of trigonometry that involve periodically repetitive phenomena, such as wave motions. So this is the modern times, alternating electric current, vibrating strings, and so on. So in this case, trigonometric functions have real numbers as their domain. So we need to extend. Okay. So this idea here, the techniques here used would be trigonometry in the case of triangles. So we have another way to discuss the 6 trigonometric functions. It is by virtue of a unit circle. Pero paano muna natin gagawing real numbers yung domains ko? Okay, para sa function ko, ay kahit anong real number na, pwede ko nang pag-aralan. Hindi na lang ako mag-aaral using the concept of angles. So I can extend the applications of trigonometry. So we need the concept here of radian measure. So if a circle of radius 1 is drawn with the vertex of an angle at its center, then the measure of this angle in radians, so rad, yung abbreviation natin, is the length of the arc that subtends the angle. So I have this figure here. So if this is theta, the radian measure of theta would be this. Kung ano yung measurement niyan. So dito, you can use degree measure to measure theta. But using the radian measure of theta, parang real number na ito because you can assign a real number here. Distansya lang naman ito. Okay? Kapag yung ikot, kapag binilang mo siya, yan, counterclockwise, yung radian measure ay positive. Kapag binilang mo siya clockwise, then the radian measure of is negative. So using the concept of radian measure, we can actually extend the domain of your 6 trigonometric functions into real numbers. Okay. Relationship between degrees and radians, we know this is already true. Yung 180 degrees is pi radians. Because of this, kapag 180 degrees tas yung radius mo ay 1, you will get a pi yung measurement. Okay? Parang nag-measure ka lang ng circumference ng half of a circle. And the following is also true. So to convert degrees to radians, you just multiply by pi all over 180. So example, so for example, ano yung 45 degrees in radians? So you multiply it by 180, pi all over 180. No, kasimple. 45 all over 180. Ano po ito? So this is pi over 4. Ganyan lang. And then to convert radians to degrees, you multiply it by the reciprocal of pi all over 180, multiplied by 180 over pi.
Hello po. Ay, pasensya po na walan daw po ng kuryente sa sa office. Wait lang po tayo saglit. Saglit lang po. Ay, okay na.
Hello. Naririnig ba ako? Sir Joy, okay na ba?
Aba, okay na. Okay na.
All right, sorry po for that. So may power interruption po ngayon sa kung saan po ako nakapesto. So I'm so sorry for that interruption. Sir, pa-pon naman ako sa screen sharing. Sorry.
Wait lang.
Co-host po ako.
Saglit. Paano ba to? Saglit lang Hindi ko... ano ba nangyayari? Pacheck. Okay na. Ayan, sige.
Host disabled participant screen sharing, sir, yung nakalagay. I-click nyo, sir, yung tab, tapos yung...
Try mo nga.
Yan, okay na. Thank you very much. So let us continue. Ituloy po natin yung lecture. Using the concept of region measure, we can now extend the textbook definition of our 6 trigonometric function values. This time, we have now our unit circle. So let T be any real number, real number na po siya, and let Pxy be the terminal point on the unit circle determined by T. So we then define the following 6 trigonometric functions as follows. So it's the same with the idea or the concept of 6 trigonometric functions of angles. In this case, meron lang po tayong a unit circle. So instead of drawing the point Pxy using this line here. So instead po na pa ganyan, so you will just measure this. So ito yung T natin. So kasi parang ito yung angle, angle theta na Hello. So let us try again. Hopefully maging stable na yung internet connection. So y sine t is equal to y, cosine t is equal to x. So in this case, what happened here would be, if I will draw something like this, because we have a unit circle, yung idea lang po dito ay itong parang hypotenuse niya, which is this. Okay? So itong hypotenuse niya, kaya nawala yung parang y over r na definition natin kanina. The hypotenuse, the measurement is just 1, something like that. So the radius is just 1 because you have the unit circle. So nagbago po yung definition. In any case, this is the 6 trigonometric functions when it comes to angles. When it comes to the unit circle. Okay. So for now, I will now discuss the fundamental trigonometric identities. So ang domain na po natin dito would be real numbers, but for special angles, because that is a special case, mag-work pa rin naman po itong mga ito. So we have the reciprocal identities, nakasabi ko kanina. The reciprocal of sine is cosecant and vice versa. Secant, cosine, cotangent, tangent. We have the quotient identities. So tangent is equal to sine over cosine. Cotangent is cosine over sine. And we have the fundamental Pythagorean identity. Sine squared t plus cosine squared t is just equal to 1. So, and we have something like this, some memes. So the idea here is ang dami namang identities. May madali bang paraan para matandaan yung mga yan? Of course, there is a way. And mas marami pa actually identities kang makikita using this technique. We call it the magic hexagon. Okay, anong sinasabi ng magic hexagon? So, let me go here. Okay, so the magic hexagon looks like this. So first, I will teach you on how to construct this magic hexagon. Ganito po yung idea. Lahat ng nag-start sa letter C ay nasa one side lang po sila. Okay? So cosine you have cosine, you have cotangent, cosecant here. Okay? Palaging nasa gitna yung mga cotangent, tangent, cosecant, secant, cosine, and sine na palaging nasa taas. And then lahat naman nag-start sa hindi letter C ay nasa left side, S, T, and S. So you draw it like this. So the first thing we need, bakit napaka-importante ng magic hexagon? Because from this magic hexagon, you can actually derive all your fundamental identities using some tricks here. All right, so tingnan natin. How will we use this magic hexagon here? The first one would be, paano natin ginagamit ito to get the reciprocal identities? Okay. So, you do it like this. So, ibig sabihin, kapag nag-drawing ka ng arrow, papunta dyan or papunta doon, this formula always works. So, sine, I will remove yung t for simplicity of discussion, is equal to 1 all over cosecant. Yan. Mag-work po ito kahit saang direksyon pag yung arrow pala. For example, going to secant to cosine. Secant here is equal to 1 all over cosine. And this is also true for all. Kapag ganito naman po, yan, tangent is equal to 1 all over cotangent. And kahit anong arrow po paloob. So you will get the reciprocal identities using this. So reciprocal of sine is sine is equal to 1 all over cosecant. Okay, so papunta dyan, papunta doon, papunta dito, papunta dyan, and so on. You can also get here what we call the product first. We can also use this to get the quotient identities. Kaya tinawag siyang magic hexagon because you can derive everything here. For example, paano natin malalaman na tangent is equal to sine over cosine? You have this trick here. You just draw an arrow going to cosine. And this works for any, kahit clockwise or counterclockwise yan. Okay? For example, kapag nag-drawing ako dito, pupunta kay Kwan, this means that cosine is equal to cotangent all over cosecant. You can verify that this is indeed a correct identity. For example, nag-drawing ako ng arrow going to, let us say, brain ko muna. Paano ba? Ito. Cosecant going to tangent. You will get cosecant is equal to secant all over tangent. This is also an identity using this magic hexagon. And you can also do this clockwise. Counterclockwise or clockwise. Ay, clockwise pala yun. Ito yung counterclockwise. Yan. This means that your cotangent is equal to cosine over sine. And you can do this for every. For example, kapag nag-drawing ako ng arrow going to that, so I have cosine equals sine all over tangent. So this is an identity. Tama po yan, kahit i-verify nyo po. Alright? That's how you remember the quotient identities using this technique. Actually, there's more. They are not fundamental identities, but they are not included as fundamental identities. Other form siya ng reciprocal identities kasi we have what we call the product identities. So, product form siya. Okay? So, in the product identities, you do it like this. So, for example, you just point an arrow. So, parang ganyan. Going to that arrow. This means that sine times cosecant is equal to 1. Ganyan po yung ibig sabihin. And this will also works for going there. Okay, kahit ano po yan, kahit anong direction, kaya tinawag siyang magic hexagon. Ibig sabihin nito, yung product ng sine, yung outside, cotangent ay equal kay cosine. This is true. And the product of sine and secant is tangent. Okay? The product of tangent and cotangent is 1. Ganyan lang po ang paggamit ng a magic hexagon when it comes to the product identities. And lastly, how do we remember the fundamental trigonometric identities? The fundamental Pythagorean identities. So ganito po yung technique. You always draw an arrow. Parang ganyan po. Yan. Going that time. Ganon. And similarly, yan. Okay? Ang ibig sabihin po ng arrow na yan, ibig sabihin po nito, ay baliktad ata. Baliktad. Okay. Ganito po pala. Yan. Yan. And then, yan. Okay. So, these arrows helps you remember the fundamental Pythagorean identities. This means that sine squared plus cosine squared equals 1. So, identities. So, I have sine squared plus cosine squared equals 1. Ito rin, since ito yung starting plus yung susunod, tas ito yung byproduct niya, which is 1. So, in this case, una yung 1. So, I have 1 plus cotangent squared, kasi going to that direction, is equal to cosecant squared. So this is another fundamental Pythagorean identity that is useful to us. And lastly, you have tangent squared plus 1. is equal to secant squared. Ayan po. Okay? And that's how you remember the fundamental identities using this magic hexagon. So parang may magic hexagon ka, ano na ulit yung product identities? Identity ba kaya itong gagamitin ko? You just use this. So you just remember the patterns. Paano kapag product, ano yung pattern? Paano kapag reciprocal? Paano kapag fundamental Pythagorean identity? Paano kapag quotient identity? You just remember the pattern and you're good to go. You do not need to memorize them. Mas madaling tandaan itong magic hexagon. You learn the patterns. Malalaman mo na yung mga fundamental identities. Okay, so in summary, so we have the following. So for product identities, we have this following pattern. So tangent times cosine is sine for product. For reciprocal, for quotient, you have this yan, naikot. So tangent is equal to sine over cosine. For fundamental Pythagorean, this is the pattern. So sine squared x plus cosine squared x equals 1. Tangent squared x plus 1 equals secant squared x. 1 plus cotangent squared x equals cosecant squared x. And of course, this sine x is equal to 1 all over cosecant x. So ito naman yung reciprocal identities. Okay? And lastly, let us discuss techniques in proving trigonometric identities. So I think after this, I will end my talk for the morning session. So in proving trigonometric identities, there are some tips. So the first one would be, start with the more complicated side and transform it to the simpler form on the other side. Often, it is desirable to convert an expression to one containing only the sine and cosine. Kasi kapag sine and cosine yung pinag-uusapan, parang napapadali yung problema because it makes everything simpler. So it's the first technique. You start with the more complicated side in proving trigonometric identities, and then you can, if it's possible, you convert it to one containing only the sine and cosine. So for example, let us prove this identity. So I have cosecant x plus secant x all over 1 plus tangent x is equal to cosecant x. So ano po yung first sabi niya na tip? Start with the more complicated side. So saan po dyan yung mas complicated? Left side or right side? Of course, itong left side kasi may plus, ito single lang siya dyan. Right? So tip 1, so I will start with the more complicated side. So this side. And sabi ng tip number 2, ang sabi niya ay, you convert everything to terms using sines and cosines only. Right? So this is now equal to cosecant x, yung magic hexagon natin, pwede nyo gamitin, ano yung reciprocal niya. So this is 1 all over sine x plus 1 all over cosine x. 1 plus yung tangent using the quotient identity, it is sine x all over cosine x, and then you just simplify, right? Using your algebraic techniques here, this is cosine x plus sine x all over sine x plus cosine times cosine x. Yan yung simplified version ng numerator. Di ba may tinatawag pa tayong butterfly technique dito. That is a topic for another day. For the numerator, I have cosine x plus sine x all over cosine x. Cancel like terms. Magka-cancel yan. Tas ito. Tas yan. Tas yan. Ang matitira ay 1 all over sine x. And we know that this is equal to cosecant x. So ganun po. That's the first technique in proving trigonometric identities. You start with the more complicated sides and then you transform all terms involving sine and cosine. The next tip would be consider the possibilities of applying algebraic processes such as multiplying, factoring, combining fractions into a single fraction, writing a single fraction having more than one term in the numerator into a sum of fractions, and so on. So you have a lot of algebraic processes. Maybe using them may be helpful. So for example, prove the identity 1 plus sine x all over cosine x is equal to secant x plus tangent x. So let's try. So ano kayang algebraic process ang gagamitin natin para mapadali yung problema? So kasi kung gagamitin natin yung tip number 1, is this side more complicated than this side? Or is this side more complicated than this side? So I'm not sure, right? Kasi parang, saan ba dyan yung mas complicated? But using an algebraic process, so for example, yung 1 plus sine x all over cosine x, pwede ko itong paghiwalayin into sum of fractions, right? For example, you can write this as 1 all over cosine x plus sine x all over cosine x. So this is the algebraic process that you will use. Paghiwalayin mo lang into fractions, into sum of fractions. And you know that 1 all over cosine x using your reciprocal identity that this is secant x. And sine x all over cosine x using your quotient identity, this is tangent x. So tapos ka na. Okay, na-prove mo na. Okay. Tip number 3, it may be more convenient to transform each side separately into the same equivalent form. So for example, magkamukha kasi sila eh. So 1 plus cotangent y equals cosecant over cosecant y equals 1 plus tangent y all over secant y. Maybe instead of working on one side, I will work on both sides, and at the end, I will show them that they are equal. Diba? You will transform them into the same equivalent form. Because if I will start here, ay parang ang hirap atang ipakita itong right side. Or if I will start here, ay parang ang hirap atang ipakita yung left side. So you work separately na lang. And at the end, you will show that they are equal. Okay lang yun. That is a valid technique. So let us see. So using the technique, 1 plus cotangent y all over cosecant y. So i-manipulate mo yan. This is now, so using the technique of converting everything to cosine and sine. So yan, 1 all over sine y. You simplify. This is cosine y plus sine y. Yan. Okay na po ata kasi I will make it fast na lang po because we do not have much time. Magka-cancel po ito kapag yan. And you can also do the same for this 1 plus tangent y all over secant y. So using the same technique, so this is 1 plus sine y all over cosine y all over 1 all over cosine y. And this is equal to cosine y plus sine y. And indeed, at the end, they are equal. So by manipulating the left side and the right hand side separately, you can show that they are equal. And lastly, to obtain a particular factor in the numerator or denominator of a fraction, you may multiply the numerator and denominator by this desired factor. So for example, this is actually a good example because it involves a mistake usually done by our students. So paano po ito prino-prove? Kasi napansin, uy, parang pwede akong mag-cross multiply dito Kasi kapag ginawa ko yun, sine squared, kapag cross multiplication, I will get sine squared x, 1 minus cosine x times 1 plus cosine x. So difference of and this is 1 minus cosine squared x. Di po ba? And then, uy, ito yung sine squared x plus cosine squared x equals 1. So, check. Sabi ng student, by cross multiplication. Okay? But let me take note that in proving trigonometric identities, this is actually an invalid proof. Bakit po siya invalid? You cannot cross-multiply when proving trigonometric identities because you can only cross-multiply if you are already sure that they are indeed equal. Okay? Ganito po yung idea ng cross-multiplication. Ginagawa lang po natin sila kapag alam natin in the first place that the quantities are equal. So parang bakit mo pa i-prove na equal sila if in the first place you are assuming or equal. So hindi po pwede ang cross-multiplication in proving trigonometric identities. So ano po yung technique dito? The idea here is we will multiply the numerator and the denominator by 1. So mali po yan, bawal mag-cross-multiply. It is invalid. So kapag nakakita po kayo na nag-prove ng trigonometric identity, tapos nag-cross-multiply, mali na po agad yon. Okay? Kasi ginagawa lang natin ang cross-multiplication kapag alam mo na in the first place na equal sila, pero in this case, kaya mo nga prove na equal sila kasi hindi ka pa sure. Okay? So it defeats the purpose of proving. So the idea here is you multiply the numerator and the denominator by 1, but that 1 will take a form. Kunwari parang mag-multiply ka ng 1. Pero yung 1 na yan will take a form of the following. So instead na 1 talaga, isusulat mo siya as 1 minus cosine x, 1 minus cosine x times 1 minus cosine x all over 1 minus cosine x is just 1, right? So parang nag-multiply ka nga lang ng 1. So there's nothing wrong here. And if you simplify, this is sine x multiplied by 1 minus cosine x. Tapos ito ay 1 minus cosine squared x. And 1 minus cosine squared x using your fundamental Pythagorean identity, this is sine squared x. Cancel mo yung isang sine squared x, you will now get your desired result, which is yung nasa right-hand side po natin. And that's how you prove trigonometric identities. And lastly, the last tip I will give would be never give up. Always try something different. So even paths that lead to dead ends provide insight. So at the end, kapag hindi mo pa rin ma-prove, try lang try. Lahat ng identities gamitin mo, try your best, use algebraic processes and so on until you have proven the desired result. Okay, so for the meantime, I think I will end my lecture here. Thank you everyone for listening. If we have time for some questions, I think the floor is now ready. Maraming salamat po sa lahat ng mga umattend sa aking lecture this morning. So sana kahit paano may mga natutunan po kayo sa akin na techniques na pwede nyo pong ituro sa ating mga students para mas mapadali ang buhay nila sa trigonometry. So uulitin ko po, mathematics or trigonometry in particular is not about memorization. If you will memorize everything, it will lead to nowhere. Later on, makakalimutan mo na siya. And kapag kailangan mo, hindi mo na siya matatandaan. But if you have mnemonic devices, if you have memory devices to remember those trigonometric function values, those trigonometric identities, mas mapapadali po ang buhay mo sa trigonometry. Maraming salamat po. Sir Joy? Nawala po si Sir Joy.
Ano ko palagi waiting mo?
Jayan, John Rick, okay na ata tayo? Sige po, may mga katanungan po ba tayo regarding to my lecture? Okay lang po mag-chat sa chat box or you can open your mic for Q&A if you have questions. Una sa lahat po ay humihingi po kami ng tawad sa interruption na nangyari kanina due to power interruption. Medyo nawala po ako sa track kanina kaya medyo yung lecture ko sa dulo ay nawala po yung momentum. So pasensya na po. So may makakatanungan po ba when it comes to trigonometry?
Hello, sir.
Hello po Sir Randy.
Sir, paano nga ulit yung easiest way para ma-memorize yung arrangement ng sine cosine doon sa hexagon po?
Ganito po yung idea. Ganito po yung idea. So, kunwari, magko-construct pa ako ng hexagon dyan. Yan. Okay. Dito po sa isang side, sa right-hand side or sa left-hand side, lahat po nang nag-start sa letter C ay andito po. So, yung cosine, cotangent, and cosecant. Okay? Tapos, kailangan nyo lang pong tandaan yung arrangement kung saan po yung cosine. For example, dito ko po siya ilalagay. Okay? Tapos, yung gitna po palagi ay yung cotangent. Parang gitna, parang tangent. Okay? Tapos, dito po ay yung cosecant. And then, lahat na po ay andito. Sa left-hand side. Ay, hindi pala naka-share screen. Sorry.
Thank you.
Nakikita na po ba? Okay, ulitin ko po. So first, let us draw a hexagon. So points lang muna ng hexagon yung i-drawing natin. And then, yan. To construct the magic hexagon, tatandaan po natin na sa isang side, sa right-hand side or sa left-hand side, I prefer the right-hand side. Andito po lahat ng nag-start sa letter C na kuwan po natin. Okay? So andito yung cosine, yung cotangent, and then your cosecant. Okay? So for example, yung nasa taas po ay palaging cosine. Yung nasa gitna ay palaging cotangent. Tapos andito na po yung cosecant. And then, dito po sa left-hand side, andito na po yung parang nag-start sa letter, yung mga hindi nag-start sa letter S. So ano po ba yung kapartner ng cotangent? Syempre yung kapartner niya which is tangent. Ano yung parang kapartner ng cosine? Yung sine. Yung cosecant, yung secant. And of course, yung 1 po ay nasa gitna. And that's how you construct the magic hexagon. Okay? Tandaan nyo lang po, andito lahat ng letter C. So cosine, cotangent, and cosecant, and you fill up the rest po using their some sort partners. Partner ng cotangent o tangent. Cosecant, secant, cosine, and sine. Okay? Ganun po i-construct itong magic hexagon. Okay? Mas madali pong tandaan itong magic hexagon kaysa po sa mga trigonometric identities natin kasi figure siya. Okay? This figure is retained in our memory. My question po dito, hi sir, can we get the soft copy of your PowerPoint for our reference? Opo naman po. Okay. The video lecture and at the same time my presentation will be available to everyone. Ibibigay ko po siya. May mga katanungan pa po ba? Wag po kayong mag-alala. Later on po, we will give a Google Drive link containing the links of the video lectures and lectures po ng lahat ng mga lecturers po. So kung wala na pong katanungan, muli nagpapasalamat po ako sa mga umattend ng lecture. See you po mamayang hapon. I have another lecture. Hopefully, mas okay na yung internet connection capability of our school. And see you po mamaya 1 p.m. for my next lecture. Sir Joy, Janrick.
Hello po. So, yung evaluation po natin para sa lecture na ito, naka-share screen po. Please accomplish this form po para ma-count yung attendance niyo for today. Salamat po.
Thank you, sir.
Sa mga hindi po nakakascan ng QR code, yung link po nasa comment section na rin po. Thank you. 1 p.m. po ang next natin na session for track A. Okay po. So kung tapos na po kayo sa evaluation form, pwede na po kayong mag-leave ng meeting and see you mamayang 1 p.m. po para sa next talk ni Professor Passion. Thank you.
Hello po, Sir Romeo.
Yes, ma'am. Morning po. Hello? Hello, ma'am. Morning.
Okay, hello sir. Yung certificate kahapon po, yun yung sa plenary talk. Kaya po siya naibigay agad. However, for lectures po, kailangan po kasi namin bilangin muna yung total attendance and before mag-provide ng certificate.
Okay. So, baling ma'am, kung 75, 3/4, ilan po ba yun? Tatlo na lang po, di ba? Tatlo, 3 days. Okay. Kasama yung morning and afternoon. Kaya
Yes
siya,
po.
okay. Sige po. Thank you, ma'am.
Thank you rin po. And see you this afternoon.
Okay.
Good afternoon po.
Good afternoon. Welcome back to the 26th SINSM of the MCS with the theme Strengthening Senior High School and Tertiary Mathematics Instruction 2.0. Okay, before we proceed to the second lecture of Professor Pasion, let me just go through a few preliminaries. For all attendees, please turn off your microphone and webcam during the talk. Please post all your questions in chat. These will be asked by the moderators at the end of each talk. Third, towards the end of the last presenter scheduled for the day, the link for the evaluation form will be posted. Certificates will be awarded to attendees who attended at least 75% of all talks in this workshop. Okay. Once again, we welcome Professor Anthony Pasion.
Thank you very much, Ma'am Jayan, for that one. So let me just share. Magandang hapon po sa ating lahat. Sana po nakikita natin ang aking share screen at naririnig niyo po ako ng malinaw at malakas. So, my topic for this afternoon talk would be on the K-12 pre-calculus course again, conic sections in polar coordinates. So, in our last SINSM, nag-discuss po ako ng conic sections in two-dimensional graph or in Cartesian coordinate system. And some participants nag-request sa kanilang evaluation na baka sir sa susunod namang SINSM ay conics naman in polar coordinates ang i-discuss nyo. Well, wish granted. So in this year's SINSM, ito po ang pag-aaralan or ang i-discuss ko po para po sa ating lahat. So polar coordinates, if I'm not mistaken, would be the last part of the trigonometry, di ba? Trigonometry part of the pre-calculus course of grade 11. So hindi ko po alam kung nako-cover pa natin ito, but in this SINSM, let's have an overview of conic sections in polar coordinates. So there are different ways to study conics. So the first one would be using just pure geometry. So this is the Greek approach. Ito po yung makalumang approach in a sense that you just define conics in terms of planes and cones. And we have another one which is, ito po yung first part ng pre-calculus natin. So analytic geometry approach. So geometric to algebraic and vice versa. Kaya tinawag po siyang analytic geometry because from geometric, gagawan mo ng algebraic and vice versa algebraic. What is it? Geometric property. So in this case, we define each conic as a collection of points satisfying a geometric property and deriving a general second degree equation from it. So if I'm not mistaken, this is the first part and my topic in last year's SINSM. So ito yung parang first part ng pre-calculus course natin sa grade 11 students natin. But in my talk, we will have another approach. We call it the unified treatment or approach. The idea here is in the analytic geometry part, iba-iba yung definition ng conic natin, depende sa type of conic because we will define it as a collection of points satisfying a geometric property. Okay? In the unified treatment or approach, we will unify it in a sense that we will start with a definition that gives a common property of conics. So I will tell what is that common property later on. And then i-introduce na lang natin yung mga conics as a special case of the general definition. So let me repeat, in the analytic geometry approach, you have 3 definitions for each conic. In the unified approach, isa lang yung definition na gagamitin natin, a special case na lang kung anong type of conic siya and so on. In this case, we can derive the polar equations of the conics in this manner. So ano nga ba yung advantage advantage ng pag-aaral ng conics using the unified treatment or approach. But before we proceed to that one, let me give an overview of the analytic geometry approach. Tingnan natin kung bakit parang ang hirap pag-aralan ng conics kapag analytic geometry. So ganito kasi yung first, the Greek approach. Ito lang yung Greek approach. So a conic section or simply conic is the intersection of a plane and a double napped cone. So I have this figure here. Ganito lang po yung double napped cone. Okay? So kapag mag-i-intersect ka ng plane tas yung cone, yan, yung hourglass na parang cone, you will get a conic. So in this case, you have your basic conic. So if you will intersect it in this way, you will get a circle. Kapag medyo slanted, yung pag i-intersect mo, you will get an ellipse. If you will do it like this, you will get a parabola. And then hyperbola kapag ganito yung intersection. So using this, we can also get our degenerate conics. So kapag nag-intersect ka sa gitna, you will just get a point. Degenerate version siya ng circle. You will get a line if it's like this, and you have two intersecting lines if you will have like this. So parang ito yung degenerate case ng parabola, tas ito naman yung hyperbola. Okay? So the point is the degenerate case of the ellipse and the circle. So there's nothing new here. You just intersect a plane and a double napped cone, you will get a conic section. So how about the geometric or the geometric into algebraic approach and vice versa? So in this case, we will describe conics in terms of the rectangular coordinate Cartesian plane system. So the rectangular system, tapos gagamit tayo ng concept ng distance or as the graphs of certain types of equations. So that's it. So you have your Cartesian coordinate system. So you have your four quadrants, your x-axis, your y-axis, and your origin. And we will just use the distance formula of 2 points. So if you have 2 points P and Q, the distance D of this line segment PQ, so sa figure po natin yan, PQ, would just be given by this one. So it came from our Pythagorean theorem. Kasi parang ito, yan, parang right triangle po yan. So the distance formula is just, the distance formula came from our Pythagorean theorem. The length of this side, the length of the square of this side plus the length of the square of this side is just equal to d squared. So it's easy. So x1, the x coordinates x1 minus x2 squared plus the y coordinates y1 minus y2 squared. It doesn't matter po kahit magsaswap yung x1 and x2, y1 and y2 because naka-square naman siya. So x1 minus x2 or x2 minus x1, it will not matter because naka-square siya. Right? So the definition of a parabola in this case is a parabola is the set of all points in a plane equidistant from a fixed point and a fixed line. The fixed point is called the focus and the fixed line is called the directrix. So ganito po yung itsura ng isang parabola. So in this case, this is the focus, this is the directrix. So the definition is this: kapag kukuha ka ng point sa iyong parabola, yung distansya niya dito sa focus ay equal lang sa perpendicular distance niya sa linyang ito, which we call the directrix. And this is all true for the set of all points na kukunin mo sa parabola. For example, dito, kapag pipiliin mo yung point na yan, the distance from this point to the focus is equal to the perpendicular distance to the directrix. Kaya po may mga ganyang linya to denote that they are equal. So this is the textbook definition of a parabola. Yan po. So, tas later on, iba rin yung definition ng ellipse and so on, depende po sa scenario. So, we have the other parts of this parabola. So we have the axis of symmetry. So this is the line through the focus perpendicular to the directrix. So in this case, this is your axis of symmetry. So parang yung axis of symmetry ay hinahati niya yung parabola mo into two parts. So the left portion and the right portion. And the vertex. The vertex is just the intersection of the parabola with its axis, which is of course is midway between the focus and the directrix. So yan po yung vertex niya. So because this is a parabola, in this case, the vertex is the lowest point or pinakamaliit na point. And the distance, so yung distance ng vertex from the focus is the same with the distance of the vertex with the directrix. We have the same figure, so the parabola. So the derivation of the second degree equation of the parabola looks like this. So if you have a point on the parabola with focus 0 of p, so ito po yung focus natin, and directrix y equals negative p, the derivation looks like this because this line segment here, yung fp, okay? Ang definition kasi natin ng parabola, yung distance from a point to the focus is the same with the distance of this to this. So parang the distance of f from p is just equal to this distance. Eh, ano po ba yung distance na yan? This one is y and this is p. So the distance will just be given the absolute value of y plus p. And from this, you can now use mathematical manipulations to derive this quantity. So ganito po yung itsura ng second degree equation of a parabola. Uy, madali pang tandaan. X squared equals 4py. Diba? Madali pang tandaan. Uy, unang tingin, kung matatandaan ko, yan yung equation ng parabola. Pero tignan po natin kung matatandaan pa natin yung iba kapag nag-derive na tayo. Okay? So this is a summary when it comes to parabola. So the graph of the equation x squared equals 4py is a parabola with the following properties. So the parabola opens upward if p is positive and it opens downward if p is less than 0. So andyan po yung mga types of parabola natin. So this is a parabola opening upward. This is a parabola opening downward. Okay, we also have parabola with horizontal axis. So the graph of this equation, so the only difference would be nag-swap po yung rows ng x and y. So in this case, I have y squared equals 4px. So this is a parabola opening to the right and this is a parabola opening to the left. Okay, hindi po tayo mag-graph ng parabola in this scenario po because I'm just introducing yung analytic geometry approach of each conic section. Kaya medyo binibilisan ko po ng konti. Okay? How about an ellipse? Ano po yung definition ng ellipse natin? So an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is a constant. So each fixed point is called a focus. So in the definition of an ellipse, you have two foci. Dalawa yung parang foci natin. So each fixed point. So the idea here is, so this is an ellipse. Ang sinasabi nito, if you have a point here, yung distance daw from the sum of the distance p to f1 plus p to f2 is equal throughout. So kapag dito naman yung pipiliin mong point, equal yung distance ng yan plus ng distance nito sa distance nito plus yung distance niyan. And this is easy to see because you can actually have a simple method of drawing. So if you find a piece of string, the length of this string is the constant referred to in the definition. Ito po, yung string na yan ay constant. If we will draw it, kapag isisingit po natin yung lapis dyan, we will draw an ellipse. Okay? Take two thumbtacks, the foci, and stick them into a piece of cardboard so that the distance between them is less than the length of the string. Now, if you will do that, the pencil traces out an ellipse. So that is an easy way to draw an ellipse. So let's derive the mathematical equation of an ellipse in Cartesian coordinate system. So let us have this figure. So I have a point P here. So point in an ellipse. So I have two foci. So F1 and F2. Yung coordinates niya ay negative Z0 and then Z0. So let the point xy be a point on the ellipse and let the sum of the distances from P to the foci be 2a. Okay, so yung idea ay from P yan, 2a palagi yan. Okay, so parang kapag sinum ko ito, if I sum the distance PF1 plus PF2, it is always equal to 2a. Bakit 2a yung ginamit? It will be clear later on. So this is the derivation from the definition, right? Sabi ko, an ellipse is the set of all points in a plane, the sum of whose distances from two fixed points is a constant. So yung constant ay ginawa kong 2a. Constant lang si a. Okay? So the distance, pf1 plus pf2 is just a constant 2a. Okay, bakit may 2 pa dyan? Bakit hindi na lang a? Kasi mas madali yung derivation kapag may 2, as seen in this one. So you can just use the distance formula here. Kaya nakuha itong quantity na yan. Plus the quantity is this from the distance formula. Take note, my coordinates ka naman. You have xy coordinate here, negative z0 coordinate here, and then z0 coordinate here. And if you will do the derivation, you will get this at the end. If you manipulate that one, you will get x squared plus over a squared plus y squared all over b squared equals 1. So, okay. So you have a manipulation here. The sum of the distances from P to the foci must be larger than the distance between the foci. Ganito yung idea. Take note, we have this idea that the sum of two legs of a triangle is greater than the third leg, di ba? So kapag sinam ko ito, yung distance na yan or yung line na yan plus yung line na to, it is greater than the distance between the two. So yung linya po yan connecting the focus F1 and the focus F2. Okay? So at the end, you will get a B is less than A. Okay? So in this case, you have, kaya totoo po itong inequality na yan. A is greater than B in our scenario. So this is an equation of an ellipse. Okay? With center at the origin. So this is the derivation. Matatandaan pa po ba natin yan? Uy, bakit iba na yung itsura niya from parabola? Yes, iba na po, di ba? The parabola, you have this form. Pagdating sa ellipse, iba na siya. You have now x squared, you have now a squared, you have now y squared, you have now b squared. Parang dumadami ata yung i-memorize ko. Yes, because you are studying a conic in Cartesian coordinate system. Okay? So we have other parts. Let me just go through this one quickly. So we have the principal axis, line through the foci. So yan po yung principal axis natin. Vertices. So in this case, you have points of intersection of the ellipse and its principal axis. So yung V1 and V2. Okay. You have your major axis. So line segment connecting the vertices. So itong line segment V1 to V2, we call this the major axis. The minor axis, yung mas maliit, connecting the point 0B and 0 negative B. And the center is, of course, kung saan yung gitna niya. Point on the principal axis that lies halfway between the two vertices. Okay? And there's a lot of things you need to learn before you can sketch the graph of an ellipse in two-dimensional plane. Di ba? Dami pa natin kailangang hanapin. Una, kailangan mo pang i-transform into this equation of the form. Kailangan mo pang hanapin yung mga vertices and so on. So, ang dami mong kailangang hanapin bago mo ito may sketch. Okay. So, in summary, you have an ellipse with center at the origin. So, the graph of each of the following equations is an ellipse with center at the origin and having the given properties. Yan po. So, let's just go through this quickly. So that is the definition of an ellipse using analytic geometry. How about hyperbola? Ito naman, ano yung definition ng hyperbola? So iba-iba yung definition nila, di ba? Parang ang hirap, ano na yung definition ng parabola, ano na yung definition ng ellipse, ano na yung definition ng hyperbola kapag ang pinag-uusapan natin ay pag pinag-uusapan natin sila in the context of analytic geometry. So a hyperbola is the set of all points in a plane. The absolute value of the difference of whose distances from two fixed points is a constant. The two fixed points are called the foci. So ganito yung idea. Okay? So if you will get a point here, if you will subtract this, kapag pipili ka ng point dyan, if you will subtract the difference, if you will get the absolute value, So parang itong F1P minus F2P, it is always a constant number. Constant palagi yung makukuha natin. Okay? That is true for all points na kukunin mo sa ating hyperbola. Kaya ganito po yung shape ng hyperbola natin because of this definition. So basically, if you want to derive the equation of the hyperbola, ganun ulit yung gagawin natin, gaya ng ginawa natin sa ellipse. So we use the definition. So we will let again the constant distance to be 2a. So parang the absolute value of this PF1, so PF1 minus PF2, you will get the absolute value so that it will become a positive number. You will get 2a. And you will get you can using your mathematical manipulations, you can derive the following equation. Naku, iba na naman yung form ng equation niya. You have x squared minus a squared minus y squared all over b squared equals 1. It turns out if you have this equation, the graph of this equation is a hyperbola. Okay. Now, ang dami. Tapos ito pa yung pinakasimpleng case kasi yung center mo ay andun sa origin. 0, 0. Paano na lang kapag yung center mo ay wala? Hindi madadagdagan ka pa ng memorize. So I have here, let's just go back. Ay tapusin muna natin. Okay, so you have this derivation. So we can set b squared equals c squared minus a squared because of this analysis. So other parts of your hyperbola, so you have your branches. Branches ang tawag kasi may dalawa kang branch. So this branch here and this branch. You have your vertices, of course, the intersection with the x-axis in this case. You have your center, in this case, 0, 0. The transverse axis is the segment joining the two vertices on the separate branches. So ito po yung transverse axis natin in this case. And the asymptotes. So the asymptotes, they are lines that the hyperbola approaches for large values of x and y. They are asymptotes in a case na they will never meet each other. So hindi po mag-i-intersect yung asymptote na yan with this hyperbola. The same is true with this one. So I have x squared all over a squared minus y squared all over b squared equals 1. So this is the equation of a hyperbola. So it looks like the equation of an ellipse. Nagkaiba lang sila sa sign dito. Okay. In summary, you have the following. So the graph of each of the following equations is a hyperbola with center at the origin and having the given properties. So yan, parang. So let me just give a few recap regarding conic sections in analytic geometry. So kapag analytic geometry yung pinag-uusapan natin, iba-iba yung definitions ng parabola, ng ellipse, and a hyperbola. And using those definitions, since magkakaiba yung definitions nila, we will get different equations for each, right? So for example, the equation of a parabola looks like this. Ganyan yung itsura niya. The equation of an ellipse looks like this. The equation of a hyperbola looks like this. So our goal for today, bakit kasi iba-iba yung definition nila? Baka pwedeng may general silang property, tas saka natin sila i-define using that general property para hindi magkakaiba yung mga equations na makukuha natin. Diba? Mas madali kung isang equations lang lahat, tas depende na lang sa general property para malalaman mo kung anong klaseng conic ito, mas mapapadali yung buhay natin, right? If we will do that. So that is the goal of this lecture. So I will introduce what we call the unified treatment para let us have a general definition. We separate each conic using that general definition so that at the end we will just have one equation sa lahat na ng conics. Kaya siya tinawag na unified treatment. Okay? So that idea is the concept of what we call the polar coordinate system. Okay? If we want to have a unified treatment, our rectangular coordinate system is not enough anymore. We need to have another coordinate system. It looks like this. So we call this the polar coordinate system. Tamang-tama yung lesson because kanina lang nag-trigonometry tayo and magagamit natin yung trigonometry to discuss the polar coordinate system. Okay. So rectangular coordinate system, of course, the grid looks like squares. So yung grid niya ay square, di ba? Yung mga grid. Sa polar coordinate system, yung grids natin would be circular in motion. Okay? It is circular in motion. So what is the use of this polar coordinate system? Tingnan natin kung ano yung advantages ng polar coordinate system over the rectangular coordinate system. But before that, ito pala. Certain curves have simpler equations in polar coordinates, as we will see later on. And it turns out, all three conics, the parabola, ellipse, and hyperbola, have one equation in polar coordinates. So imagine that one. Kapag Cartesian coordinate system, iba-iba yung itsura ng mga equations ng mga conics natin. Pero kapag pinag-aralan natin sila in the polar coordinate system, isang equation lang pala yung pag-aaralan natin tas makukuha mo na yung mga conics mo. It makes our life easier. Okay, so that is our main goal. So the first thing we need to learn would be how to form the polar coordinate system in the plane. So how will we form it? Paano po natin mabubuo yung polar coordinate system? So in general, the polar coordinate system looks like this. So we will transform the xy coordinates into coordinates r theta. So here are the steps. So the first one would be, we will fix a point O. We call this the pole or origin. But since we are dealing with polar coordinate system, mas madalas pong gamitin itong term na pole. So the pole is just the center. Kung saan po nag-i-intersect itong mga rays na yan, itong mga linyang ito, we call it the pole. Okay, so andyan po yung O natin. So in this case, yan yung O natin. So that is the first step. The next step would be, we construct from O an initial ray called the polar axis. So if you will have this line, so if this is your O, and if you will construct an initial axis or an initial ray, yan. Ang tawag po natin dyan, this is ray lang po siya, hindi po siya double ray, kaya hindi na po natin extend dito. Okay, we call this our polar axis. Okay, so in the Cartesian coordinate system, we have two, parang may dalawa tayong x-axis tas y-axis, tas may origin. But when it comes to the polar coordinate system, parang dalawa lang yung kailangan natin. Okay, the first one is your pole and your polar axis. How do you construct your points in the polar coordinate system? So each point P in the plane can be assigned polar coordinates r theta as follows. So paano po natin kino-compute yung r theta in this manner? So r is just the directed distance from O to P. So from your pole to your point P, just measure it. Ano po yung distansya niya yan? That is your first coordinate in the polar coordinate, it is r. And then theta would just be the directed angle. So the directed angle would be counterclockwise from the polar axis to the segment OP. So this is your segment OP. So ito na po yung theta. Theta natin. So if I will have a point here, okay. Kunwari kapag pipili po ako ng point dito, let us say my point here, yan. Yung R ay yung distansya na yan. Kung ano po yan, ito yung R. Tapos kung ano man ito, Yan yung theta. So you describe this point in the polar coordinate system as your r theta. And that's how you construct. So let's just have some examples here. Okay, this one. So in this first example, I have the point. So this is the point. Yung point ko dito ay yung 2 pi over 3. Yusin lang natin. Yan. So this point here refers to this point. So yung theta natin dito kasi ay pi over 3. And the measurement of this one, if you will measure, because this is 1 unit, this is 2 units, so you have 2 pi over 3. Okay? So ito po yung r. Tapos ito po yung theta. Okay. So this is also the point 3 negative pi over 6. So in this case, yung theta po natin ay measure natin instead of counterclockwise, we measure it clockwise. Kaya naging negative pi over 6 po siya. Okay, so the unit is 3 units. So 1, 2, and 3. But since you measured, kasi pwede mong i-measure yung angle, di ba? Counterclockwise or clockwise. Kapag measure natin siya clockwise, you will put a negative sign here. So you have negative pi over 6. And you will notice here, okay? And you will notice here, this is also the point. (11 pi over 6). So kapag measure mo kasi yung angle mo counterclockwise, 11 pi over 6 yung makukuha mo. Pero kapag measure mo siya clockwise, you will get a negative pi over 6. So you will notice here, this point is the same as this point. Di ba? Parehas sila. Kasi they are referring to the same place in your polar coordinate system. But they have different representations or names. Okay? So dito, 3 negative pi over 6. Ito, 311 pi over 6. So, iba yung pangalan niya dito. Iba yung pangalan niya dito. So, they have different representations, but they are referring to the same point. Okay? So, we have this basic observation here that observation that in polar coordinates, a point r theta has multiple representations. Hindi lang iisa. Na pinagkaiba niya sa rectangular coordinates natin. In our rectangular coordinates, each point xy has a unique representation. So for example, kapag meron akong if I have my Cartesian coordinate system here, xy, if this is my point negative 1, 1, yeah, negative 1, 1, this point, okay, has a unique representation. Ang representation niya lang or ang pangalan niya ay negative 1, 1. Okay, wala nang iba. Okay, there's no point here or there's no representation that will represent this at the same way. Ito yung pinagkaiba niya sa rectangular coordinate system because in polar coordinate systems, it can have multiple representations. Actually, it is infinite. Okay, as given in this example. So parang ito. Yan. Let us study. This point here, okay, this point is the point 3 negative 3 pi over 4. 3 pi over 4 kasi measure mo yung angle clockwise. Tapos yung measurement ay 3. Yung yan. But it is also equal to 3, 5 pi over 4. Bakit equal? Kasi negative 3 pi over 4 is the same with 5 pi over 4. The only difference would be yung 5 pi over 4, measure ko siya counterclockwise, while this one, I measured it clockwise. So they are representing the same angle to be in general. But this is also equal to negative 3 pi over 4. Ganito po kasi yung idea kapag negative yung r. Okay? So, una, I will draw here something. Ay, hindi nag-match pero just imagine ganyan siya. So, this point here, this is the point kapag ito ay pi over 4, this is the point 3 comma pi over 4. Right? Pero kapag gagawin nating negative itong 3, instead of doing it like this, you will do the opposite. So parang yung opposite siya ng ray. It's the mirror image. So kapag negative r yung pinag-uusapan, it's the mirror image of your r. Kaya po siya na-plot dito. So negative 3 comma pi over 4 is plotted here because of this. Yung parang kanina lang na ginawa natin, kapag positive yung angle, counterclockwise. Kapag negative, clockwise. Kapag positive yung r, in this direction. Kapag negative, it's the opposite direction. Okay? Opposite. Yun po yung ibig sabihin ng positive, negative na angle. Yun po yung ibig sabihin ng positive or negative na radius. You draw it on the opposite side. So mirror images sila. So this is also equivalent or equal to the point negative 3 comma negative 7 pi over 4. Kasi yung pi over 4, yan. Pero kapag measure mo siya, pag ganun, pabaliktad, it is negative 7 pi over 4. Okay. So the question here would be, sir, hindi ba mas pangit ang polar coordinate system kaysa sa rectangular coordinate system? Kasi kung ganyan, bakit ko pa pag-aaralan yan? Isang point ang dami-dami niyang representation. It's okay. That is the case. Kasi marami man siyang representation, yung representation naman na yan, they refer to the same point. Yan lang naman yung pinag-uusapan nating point. Okay? So kahit marami siyang pangalan or pwede mo siyang i-represent in many ways, we are still referring to the same point, which is not a problem. So actually, hindi siya disadvantage ng polar coordinate system. There's no issue actually in this case. Okay? So, ganyan po mag-locate ng points sa polar coordinate system. Your r is just the directed distance. Your theta is the directed angle. Okay. So, what is the relationship between rectangular coordinate system and polar coordinate? So, the idea here is, how do you convert? For example, I'm given a rectangular coordinates, x, y. Paano ko siya gagawing polar? Okay, and vice versa. Paano kapag may polar ako, gusto ko siyang gawing rectangular? So, ito yung relationship kasi. So, for example, I have my xy axis, and at the same time, I have also my polar coordinate system here. So, may origin tayo, tas may polar axis tayo. Okay? So, notice here that we have a right triangle. Kapag trigo talaga, paborito ang right triangle kasi ang dami nating natututunan dito. Ang dami nating pwedeng gamitin na tools. Okay? So, this is your x. Ito yung xy. So, tas ito rin yung r theta natin. So, what is the relationship between them? Okay? If you will measure the distance from this x-axis to this point is y. Ito yung x natin. So, the distance from the pole to this point x is x. And of course, this is your r. Right? And you have your theta here. So, we have the relationship first. Okay. So, ay, hindi siya nagsusulat ng maayos. Okay, so let me just say, from the Pythagorean theorem, so we have from this figure, yung r squared is equal to x squared plus y squared, right? Ito pa yung first natin. Okay, the length of this side, which is r, is equal to the sum of squares of this side plus this side because we have a right triangle here. Okay, ano po yung masasabi natin dito? We also have our SOHCAHTOA, right? Na napag-aralan lang natin kanina. So the first one would be, I know that sine theta is equal to opposite over hypotenuse. So ano po yung opposite ng theta? Opposite, yung side opposite niya ay y. So I have y over r. What is cosine theta? Cosine theta is just adjacent over hypotenuse. So ano yung adjacent na side? X. In this case, hypotenuse is r. So I have x over r. And lastly, I have my tangent theta. TOA, opposite over adjacent. So opposite over adjacent, I have now. This is equal to y over x. So these are the relationships we need to convert from a rectangular system to polar coordinate system. All right. So from polar to rectangular, you will use the identities kasi makukuha mo si x using these identities. So itong cosine theta x over r, you just multiply r both sides. You will get x equals r cosine theta. Kasi from polar to rectangular, given yung polar, so meron kang r theta. Using these two equations, you can compute your x and y coordinates. Okay, so you will use this for polar to rectangular. How about the other way around? So ito, ginamit natin, itong dalawa, ginamit natin from polar to rectangular. If it's rectangular to polar, you will use the relationship. To get theta, you will use this relationship, y over x. And then to get your radius or your r, you will use this x squared plus y squared. Kasi kapag rectangular to polar, given naman dito yung x and y coordinates. So para makuha mo si theta, tangent theta equals y over x. So mag-tan inverse ka. And then in order to get r, x squared plus y squared equals r squared. So ganun lang kasimple po. So this came from this figure here. So polar to rectangular, yan. Rectangular to polar, itong dalawang equations na to. So examples. Convert to rectangular coordinates, convert to polar coordinates. All right, so okay, so polar to rectangular. So let me just recall the formula. I have here x equals r cosine theta, y equals r sine theta. All right. So let us just solve, use this. So in this case, r is equal to square root of 3. Tapos yung theta ko ay equal sa pi over 6, right? Kasi ito yung r, ito yung theta. Plug and play. Ganun lang kasimple. I-substitute mo, you compute, the end. So in this case, I have x is equal to, using r cosine theta, square root of 3 cosine pi over 6. Okay. Y is equal to square root of 3 sine pi over 6. Okay. Sir, pero hindi nyo kami tinuruan paano mag-compute ng trigonometric function values kapag gradients yung binigay. It's up to you kung ano yung gagawin mo dyan. You can convert to degrees kasi mas kabisado mo yung degrees, or baka na-encounter mo na itong mga ito. So, pi over 6 is, ano ba ito in radians? In degrees. Ganun lang. Mag-multiply ka lang ng 180 over pi, you will get 30 degrees. Alam mo na yung cosine 30 degrees, right? So, this is just square root of 3 cosine 30 degrees. Hand trick. Gamitin ulit natin yung hand trick. Saan dito yung 30 degrees? 0, 30. So, fold. You count the numbers above. 1, 2, and 3. So, you have, this is now square root of 3 times square root of 3 all over 2. Let us simplify. This is now 3 over 2. Square root of 3 times square root of 3. Square mo yan. Magka-cancel yung square root all over 2. How about this? Sine pi over 6. So, you count the numbers below. 1. So, you have square root of 3. So, 1/2 na yan. And this is equal to square root of 3 all over 2. Ganun lang po mag-convert from polar to rectangular. So, in other words, this point, kapag PR theta, P square root of 3 pi over 6, in the Cartesian coordinate system, this point refers to the point xy, where x is your it refers to the point 3 over 2 square root of 3 over 2. Check nyo lang po kung may maling computations po. Paki-check na lang po. And that's it. How about rectangular to polar? So, you have this rectangular coordinate system, negative 1, 1. How will you convert this to polar coordinates? So, negative 1, 1. So, yung xy ko dito, so I have xy which is equal to negative 1, 1. So, yung x is negative 1, y is 1. So, I will just use, to get theta, I will just use tangent theta, which is y over x. And to get my r squared, your r, you will just use r squared equals x squared plus y squared. Okay. Okay. So first, let us have a visual representation. Hanapin muna natin yung negative 1, 1. So yung negative 1, 1 ay andito kasi kunwari andyan si negative 1, andito si 1. Yan po yung point na negative 1, 1. So kapag gagawan ko siya ng r theta, it refers to this. So ano po yung distance niyan, ano po yung angle na tinutukoy dito. Right? This visual representation is very helpful kasi kapag nag-substitute ka dito ng tangent theta, makukuha mo lang dito ay negative 1 all over 1, which is negative 1. Right? And some of way, parang ang hirap namang hulaan si theta kapag ganito, lalo na kapag hindi tinuro sa inyo yung trigonometric inverses functions of trigonometric functions, di ba? Kapag wala kang idea ng trigonometric inverse functions. But in this case, it's very helpful kasi alam mo na yung theta is in quadrant 2, right? So kapag i-measure mo siya counterclockwise. So this means that ano yung angle na yan? In such a way, you will get negative 1 all over 1. Okay? So, the answer here would be okay. So, the answer here would be theta now is equal to, okay, kasi parang ano yung theta in such a way that, okay, -1. Kasi mayroon kayong identity ng sin theta all over cosine theta is equal to -1 because this is your tangent theta, di ba? Equal siya dyan. So mag-isip ka ngayon, ano yung alam kong special angle? In a sense na kapag niratio ko, yung sin theta niya and cosine theta niya, the result is -1. Or just ignoring the sign, ano ba yung alam kong special angle na kung saan kapag nag-ratio ako ng sin cosine, ang sagot ay 1. Okay? That will only happen if the numerator is the same with the denominator. And I just know one special angle. Yung mayroong sagot na square root of 2 over 2 plus square root of 2 over 2. Right? So, and that is 45 degrees. But take note, it is in quadrant 2. So, ano yung parang angle dito na yung corresponding reference angle niya ay 45 degrees. And that is yung 135 degrees. Right? So, just kapag wala kang idea ng inverse trigonometric functions, mag-analyze ka na lang. Okay? You may convert this into radians para mas magandang tignan. And this is equal to, correct me if I'm wrong, I think this is 3 pi all over 4. Tama po ba? 135 multiplied by, yan, tama po. 3 pi all over 4. Ay, tama ba? -1, 1. Okay, tama. Dito siya sa quadrant 2. Okay. So I have now my theta. Yan na yung theta ko, yung R na lang. So R is plug and play. So tanggalin na natin dyan kasi in-square root ko na. Plug and play. So I have -1 squared plus 1 squared. This is, I think, square root of 2. So, yung -1, 1 is the same with, so ito yung Cartesian ko. Yung polar ko naman, square root of 2 plus 3 pi all over 4. That's how you convert a polar to a rectangular, to polar. Okay? Pero to be honest, hindi naman talaga tayo nagko-convert. Kapag nag-polar ka na, polar mo na siya pag-aralan, ba't mo pa i-convert sa Cartesian? Kapag Cartesian ka na, doon mo na siya pag-aralan, bakit mo pa i-convert sa polar? Okay? Something like that. Okay. So ito na. Graphs of polar equation. So the first idea, why do we need a polar coordinate system? Because there are certain curves na may kapag pinag-aralan mo sila sa polar coordinate system, they actually have simpler equations. Let me give you an example. Let us consider the polar equation R equals 4 sin theta. Okay. Tapos pag-aralan natin. So let us use pick a point method. So given theta, malalaman agad natin si R, di ba? Kasi pwede kong i-substitute dito. I-substitute dito yung theta, makukuha ko si R. And let us try this for different values of theta. Yung isa-substitute lang natin ay yung may mga reference angle na special para ma-compute natin siya without using our calculator. So 0, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi over 6, 7 pi over 6. So just pick a point, theta, you solve for R, you will get the following table. Madali lang po ito kasi plug and play lang. For example, 0, what is sin 0? Sin 0 is 0, so 4 times 0, 0. What is pi over 6? Sin pi over 6 is 1/2. What is 4 times 1/2? It is 2. So in other words, you can complete this table easily. Kasi may mga techniques na tayo on how to solve the sine of value of the following special angles. So plug and play lang po tayo because we have chosen special angles. Now you have your theta, you have your R, you can plot this in your coordinate system, in your polar coordinate system, right? Kapag plinat po natin yan, magbibigay ako ng example later, na iba, but for now, you will get this figure. For example, saan po si 0, 0? R theta. Yan po yan. Okay? Saan po si 2 pi over 6? Yung point na po yan. Ito po si 2 pi over 6. Saan po si 3 pi over 3? Ay, saan po si pi over 3, 2 square root of 3? Yan po. And if you will complete this table, you will get a circle. Just imagine it like this. Sa polar coordinate system, nag-pick a point method lang tayo, nag-graph na natin yung circle, nakita na natin yung pattern. Now let us convert this into Cartesian coordinate system. Itong r equals 4 sine theta para makita nyo po yung importance. Okay? Ito ay equal ka, yung sine theta, pwede ko siyang isulat na y over r, di ba? Yan, y over r. Sine theta is just y over r. Multiply both sides by r squared, you will get r squared equals 4y. Ano po yung r squared? We know that this is x squared plus y squared. Is equal to 4y. X squared plus y squared minus 4y is equal to 0. I-complete lang po natin yung square. So this is x minus 0 squared. Y minus 2 squared. Tapos meron po ako ditong equal to 4. You can do this easily. But for the sake of discussion, gamitin natin. So in other words, the Cartesian equation of r equals 4 sine theta is this. Alam natin na ito naman talaga yung equation of the circle. But my point is this one. Kaya ba nating i-plot itong circle in the xy plane na gagamit lang tayo ng pick a point method? Pick many points, ma-observe ba natin yung pattern? I think hindi kasi kung mapapansin nyo, let me just erase. So ito po yung Cartesian equation. Now, can we do the same technique? Kunwari, gagawa ako ng table ko dito. X, Y. Kunwari, 1. Tapos, masasolve ko ba si Y? Madali bang isolve si Y? Kunwari, X is 1. Pipili ako ng mga points ko na 1, 2, 3, 4, 5, 6. Can I solve Y easily? Kapag Cartesian equation yung gagamitin ko? I doubt. Kasi baka nga kay 1 pa lang, susukuan ko na siya eh. Kasi kung mapapansin, sinubstitute ko dyan si 1. Naku, naka-square pa. Y minus 2 square. So mag-square root ka pa, ililipat mo pa yung 2, hindi mo pa makukuha yung exact value, and so on. Right? So, kapag nag-sketch tayo ng circle sa Cartesian equation, hindi ito yung technique na ginagamit natin. We do not use this one. Right? Pero kapag mag-sketch tayo ng circle in polar coordinate system, mag-work pala yung mag-work pala yung pick a point method. So pick theta, solve for r, you collect them, ma-observe mo na agad yung pattern. So certain curves have simpler equations in polar coordinates. Mas madaling aralin, lalo na yung may mga shape na bilog. Kasi kung gagawin mo yan dito, naku, wala kang patutunguhan. Ang hirap isolve niyan, mano-mano pa. Dito, kaya nating imano-mano. Okay? So let me give one example here to show. Try nating gawin. Consider the polar equation. So 2 minus 2 sine theta. Check po natin. Yung ginawa lang natin kanina, Okay. So before we solve this, tignan nga natin kung gaano ka-complicated yung Cartesian equation natin para magganahan naman tayo na pag-aralan na lang ito sa polar system kaysa sa Cartesian system. So let us try to convert lang. Let us see kung magagawa po natin. So ano po kaya yung Cartesian equation ng r equals 2 minus 2 sin theta? So 2 minus 2 sin theta, ito ay equal kay, so r is equal to 2 minus 2. Pwede ko itong palitan ng y over r. Similar. Tapos ito na ngayon ay r squared equals 2r. So multiply, multiply, minus 2y. Okay. So this is x squared plus y squared because r squared is equal to x squared plus y squared. Plus 2y, lipat po natin dyan. Tapos ito na ay two. R lang siya. So meron akong 2 square root of x squared plus y squared. Since ayaw kong may square root, square ko siya. Square ko to para equal siya kay 4 x squared plus y squared. Okay, I think lahat po ay x and y in variables na. So you will notice this is your Cartesian equation. Now imagine studying this equation. Ang hirap niyang pag-aralan kasi x squared plus y squared plus 2y tas naka-square pa. So itong x squared magiging 4th degree pa yan. Itong y squared since naka-square, basically you have a degree 4 equation. Napaka-complicated na niya kung pag-aaralan pa natin siya. But actually, madali siyang pag-aralan kapag ito yung pag-aaralan mo, the polar equivalence of this Cartesian equation. O check natin yung kanina, yung pick a point lang tayo para madali yung buhay. So check natin kung mag-graph natin siya. Okay, so ayan po yung Cartesian equation natin. So complicated na. So let me just copy. So I have equals to, mas maganda sana kung dito kayo susulat. Okay, let me just clear this para hindi po mawala yung polar graph dito sa tabi. Okay, so I have r which is equal to 2 minus 2 sin theta. Okay, pick a point. So theta, let us say 0 pi over 6. Let us just complete. Para po mas madali, isulat natin siya vertical. Plus pi over 2, 2 pi over 3, pi, and let's continue this. 4 pi over 3, 3 pi over 2. Pi over 6, may nakalimutan ako. Itong 5 pi over 6. Pi over 2. 5 pi over 6. Plus pi, and then 7 pi over 6. 3 pi over 2. 5 pi over 3. And then, nako, ang haba pala. Pero wag po kayong mag-alala, madali lang itong fill up. Okay. So, R, let us solve each individual. Tandaan po natin yung equation 2 minus 2 sin theta. Yan. Kapag theta is 0, what is R? Plug and play. Sine 0 is 0. So 2 minus 0 is 2 minus 0 is 0. Pi over 6. Pi over 6 is 1 half. Sine pi over 6 is 1 half. So 2 minus 2 times 1 half. So you will get 1. So 1 yan. If it's pi over 2, nakalimutan ko si pi over 3 dito. Sige, mamaya na natin isingit. What is pi over 2? Pi over 2 would be sine 90 degrees, 0. Ay, sine 90 degrees is 1. Ay, mali pala. Kamali ako. This should be 2. I'm sorry for that mistake. Kasi 2 minus 2 sine theta, tama. Sine 0 is 0 plus 2. Okay, okay. Pi over 2, ito pala yung 0 na part. Plus 2 pi over 3. What is 2 pi over 3? So 2 minus 2, 2 minus 2 sine 2 pi over 3. Ano ba ito? Two minus 2. Hindi na siya exact. Okay. 2 minus okay. So let me just write. So this is 2 minus square root of 3. 5 pi over 6. I believe this is 5 pi over 6 is 1 half. Okay. Pi is okay. What is sine pi? Sine pi is negative 1. Ay, mali. 0. So this is 2 also. Okay, 7 pi over 6. 7 pi over 6 is negative 1 half. So 2 times negative 1 half. 3. 3 yan. Tapos ito ay 2 plus square root of 3 if I'm not mistaken. 3 pi over 2 would be 3 pi over 2 sine 2 plus 2 would be 4. 5 pi over 3 would be yan. Tapos 2 pi, bumalik na po tayo dito. Okay. So let us locate the following points and let's see kung may pattern tayong makukuha. Okay, kapag theta 0, 0, 2, saan po yung 0, 2? So let us say this is 1 unit, this is 2 units. So 0, 2 is this. So i-point lang po natin. Next, pi over 6, 1. Pi over 6, 1. Ito po yung pi over 6. So 1 unit. Ayan po. Okay. Pi over 2 is 0. Yan. Wag na ata nating sketch itong 2 pi over 3. Kasi ayokong mag-compute ng 2 minus square root of 3. So yung 5 pi over 6 na lang. 5 pi over 6 is 1. Bakit 1 half ito? Mali, that should be 1. That is 1. Sorry for that mistake. Yan. Okay, dito siya. And then pi is 2. Pi is 2, yan. Okay. 7 pi over 6 is 3. Okay. 3 pi over 2 is 4. So 1, 2, 3, 4, 4 units. 11 pi over 6 is 3. 11 pi over 6. Yan. And 2 pi, bumalik na po tayo. So ganito po yung itsura. Ano po kaya kapag kinonect ko po yung dots, ano po yung makukuha natin? You will get? Of course, the ideal here is, I will connect it like this. Ako, dun lang ako. Yan. And you will also do the same. And you get a heart-shaped graph. Okay? So, using using set of points, pag-graph natin siya. Pero kapag yung Cartesian equation, hindi po natin makukuha yung graph na yan. Right? Kasi, from this set of points, ang dali pa lang i-observe yung pattern. Okay? And ito po, na-compute natin siya using just our special angles. Right? And that's it. So, this is an example wherein, oo nga, kapag polar yung ginamit mong equation, madali siyang i-graph sa polar coordinate system. Kaysa yung Cartesian equation niya na ang hirap-hirap i-graph sa Cartesian coordinate system. So, I repeat, an advantage of this would be advantage, certain curves have simpler equations in polar coordinates. We do not have much time. Gusto ko pa sanang gawin itong mga B, C, and D. But let us just use wind plot para makita natin kung ano yung mga plot ng mga yan. Saan yung wind plot ko? Yun. Nakikita po ba yung wind plot? So wind plot is downloadable, free naman po siya. So this is just an illustrate process. So this one has a polar coordinate. Polar. So for example, i-graph po natin itong, let us say, mamili na lang po ako itong letter D. Itong 4 cosine 2 theta all over 3. So I have 4 cosine over 3. Let us say negative 4 pi to 4 pi. Ano po kaya yung shape niya? Yan po yung shape niya. Uy, amazing. So, hindi po natin nagawa, but if you will describe this shape, ano po yung description ng shape niya yan? It looks like an intersection of 4 hearts, right? Nag-intersect. Yan, heart number 1, heart number 2, heart number 3, and then heart number 4. And maganda po yung intersection because the shape of the intersection is actually a 4-leaf rose. Parang rose po yan. This one, and this one. Kasi kapag tatanggalin ko po yung over 3, yan, makukuha po natin yan. Right? And believe me or not, kaya rin po nating i-graph itong mga ito gamit lang po yung technique natin kanina na pick many points, use your special angles, mag-graph po natin yung mga yan. We can observe the pattern easily. All right. Okay, so this is now the last part of my talk. The alternative definition of conics in polar coordinate system. Kasi sabi ko kanina, mas madaling pag-aralan ang conics sa polar coordinate system kasi isang equation lang yung pag-aralan natin. So this is the alternative definition. So let F be a fixed point. So meron pa rin tayong focus, meron pa rin tayong directrix. Ito na yung defining property common to them all. So let E be a fixed positive number. We call this the eccentricity of your conic. Okay? Yung E, the set of all points P such that E, so PF over PQ, this is the ratio of the distance from F to the distance from L is the constant E. Okay? This is a conic section. Okay? So Itong eccentricity pala, this is the common property of all conics. Tapos, kung ano yung value ni E, yun lang yung magdetermine kung anong conic siya. For example, the conic is an ellipse if E is less than 1, if the ratio is less than 1. The conic is a parabola if E is equal to 1. The conic is a hyperbola if E is greater than 1. Okay? So just imagine this alternative definition of conic. Sinasabi nito na if you know your letter E, the eccentricity, it's enough to determine the type of conic you have. Kapag less than 1, ellipse. Kapag equal to 1, parabola. Kapag hyperbola, E greater than 1. Hindi mo na kailangang mag-aral ng napakaraming equations. Ano yung eccentricity niya? Tanong mo lang sa sarili mo, alam mo na agad kung anong klase siyang conic in the first place. Okay, ganito yung idea. So, ito kasi yung ratio ng PF over PQ. So, it is less than 1. Ito yung PF over PQ. Obvious naman na mas maliit yung PF kay PQ, kaya naging less than 1. Ito equal sa definition ng parabola. Tapos sa hyperbola, greater than 1. Okay? Sukatin nyo lang yung PF over PQ. PF over PQ. Obvious naman na mas maliit yung PQ. Okay? And if we will use this alternative definition of conics, we can actually derive the following polar equation of conics. Ito lang pala yung form niya. All three conics have one equation in polar coordinates. So the graph of a polar equation of the form r equals EP over 1 plus minus cosine theta, r equals EP 1 plus minus sine theta is a conic. Okay? Where E greater than 0 is the eccentricity, itong absolute value of P is the distance between the focus at the pole and the directrix. So if you see an equation of this form, automatic conic na yan. Pero sabi niyo, sir, isa lang. This is considered one equation kasi they only differ kapag cosine or sine siya. Diba? EP all over 1 plus minus cosine theta, R equals E times P 1 plus minus sine theta. Okay? So the idea here is you place one focus at the pole. And with this equation, ang daling pag-aralan ng conics because ang dali nilang sketch sa polar coordinate system. Ito lang yung steps. Sketching a conic in polar coordinates. So the first one is identify the conic by finding its eccentricity. Step number 1. Plot the points for which theta equals 0, pi over 2, pi, and 3 pi over 2. Yan lang yung step na kailangan mo ma-sketch mo na yung conic sa polar coordinates. 2 steps lang, sabi niya. First, you identify the conic. I-plot mo lang daw yung points nito. And using number 1 and 2, you can now have a general idea of the shape and location of the graph. So let me just give a few examples. I think 3. So gawin po natin before mag-time. Ito. R equals 1 minus sine theta. So isulat ko lang po yung general form. So E times P 1 plus minus sine. Para hindi tayo magkamali. 1 plus sine theta. R equals EP 1 plus minus cosine theta. Okay. Okay. In this case, ano po yung eccentricity natin? Nasa form na ba siya na 1 plus minus sine theta? Okay. So I have here R equals 6, 1 minus sine theta. So naka-proper form na po siya, di ba? So in this case, I have parang may kulang yung equation ko. May kulang ba ito? Let me just check. Sabi ko na nga ba may kulang. Okay? I'm sorry for this mistake. There should be an E here para ma-identify agad natin yung conics. Let me just annotate. It should be, let me just correct this. Yan, mayroon po palang E dyan. I will correct this later on bago po namin ibigay yung kwan. I'm sorry for not placing it there. Yan. Ito po, pakisulat na lang po. So, EP all over 1 plus minus E cosine theta, EP 1 plus minus E sine theta. Okay? So, let me just go back. Okay, so dyan na yung equation. So, I have now here E. Kasi mayroon tayong E dito, tapos mayroon na siyang 1 minus sine theta. Ano ba yung katabing number ni sine theta? Obviously, your eccentricity here is now equal to, E is equal to 1. In other words, this is a parabola kasi the eccentricity is 1. Okay, kailangan pa ba nating i-compute yung P? Hindi na daw. Okay, you just plot the points. Solve mo na lang si theta 0. Solve mo na lang si pi over 2 kay 3 pi over 2 pi and then 3 pi over 2. Yan. Plug and play. So for example, if r is 0, if theta is 0, what is r po using this equation? Plug and play, you will get what is sine 0? Sine 0 is 0, you will get r equals 6. So 6 po yan. If it's pi over 2, okay. Kapag pi over 2, wala pong value, right? So, markahan po natin yan. Bakit wala pong value kapag pi over 2? Ibig sabihin, hindi po dadaan doon yung graph natin. Kasi, kapag sinubstitute mo yung pi over 2 dito, you will get 6 all over 0. Right? So, wala po siyang value. How about pi? If it's pi, you will now have okay. If it's pi, 6 po ba? Tama po ba? 6 pa rin. If it's 3 pi over 2, we have a value here because kapag 3 pi over 2, you will get a negative of negative 1. So r is 3 in this case. So yan. Let us just fix that point. So 0, 6. So saan po yung 0, 6? By 2's na lang po tayo. So 2, 4, 6. So andyan po yung 0, 6. Zero pala. Pi over 2, wala, hindi dyan dadaan. Pi, 6 pi, so ganun rin po, ulitin natin dito. So 2, 4, 6. So ito yung 6 pi. And lastly, you have 3 pi over 2, 3. So 2, so andito po yung gitna yung 3. So this is your 3 pi, 3 pi over 2. Okay? And dahil alam natin that this is a parabola, how will you have a parabola if you have 3 points like that? You just draw. Ako hindi umabot. Okay? Yan po yung parabola natin. As last example, sorry for extending, sagutan lang po natin ito. Last na po ito. So how about this? R equals 3. Uh, 10 all over 3 plus 2 cosine theta. So the first thing we need to do here, kailangan i-transform natin siya into the general form na R, EP over 1. Kailangan 1 po yung number dito. Since hindi 1, kailangan nating baguhin. cosine theta. So this is the form. So the idea here is we multiply the numerator and then the denominator by 3, 1/3. So meron kang 10 over 3 dyan. Tapos ito ay 3 over 3 plus 2 over 3 cosine theta. Okay. And from this, you have now 10 over 3 all over 1 plus 2 over 3 cosine theta. And this is now equal to yung eccentricity, kung ano po yung number na katabi ng cosine theta kapag 1 na po ito. You get E equals 2 over 3. Is 2 over 3, what is the relationship between 2 over 3 and 1? Mas maliit po itong 2 over 3, so you have less than 1. And from our definition, if the eccentricity is less than 1, this is an ellipse. Ellipse po yung kakalabasan nito. And ganun ulit po. So plot the points. You have theta 0, pi over 2, pi 3 pi over 2. You just solve for r. You locate them here para magkaroon ka po ng general idea. So what is, bilisan lang po natin. So ano yung equation? 10, 3 plus 2 cosine theta. Okay. If theta is 0, what is r? Theta is 0, so cosine 0 is 1. So 10 divided by 5 is 2. If it's pi over 2, 10 over 3, tama po ba? If it's pi, I think this is 3 minus 1. So this is 10. And then 3 pi over 2, substitute 3 pi, cosine 3 pi over 2 is 0. So 10 over 3. Approximately 3 point something, sabihin na lang natin, ito ay approximately 3 point something. Okay? And you locate those points in your, dito sa ating polar coordinate system. So where is the point 2, 0? Okay, ito na lang yung gawin nating 2, 0. Para 2, by 2s na lang tayo. So 2, 4, 6, 8, 10 para umabot. Where is the point 10 over 3? So 3 point something. So 3 point something pi over 2. So 3 point something pi over 2. So somewhere here, maybe. Okay. Tapos pi 10. 10 pi. So I have 2, 4, 6, 8, 10. Oh, sumakto nga. Ito yung 10 pi. And lastly, I have the point 10 over 3 ulit. So kopyahin ko lang yung nasa taas. So this is your 10 over 3 pi over 2. This is your 10 over 3, 3 pi over 2. And I think I have now a general idea of my ellipse. So from these points, paano po tayo makakaguhit ng ellipse dito? You just connect them. Paano ba? So, ganyan siguro ay hindi umabot. Ayusin na lang po natin later on. But you have a general idea. Yan. Okay. So, ang dali, di ba? Ang daling mag-sketch ng parabola ng ellipse kapag polar coordinates. And lastly, you can also do po the last example. This one. In this case, you will get a hyperbola po using the same techniques. Okay? And I think I will end my talk here. Maraming salamat po sa pakikinig. Kung may mga katanungan pa po tayo, maaari na po tayong magtanong. So, in conclusion, introducing the polar coordinate system makes our life easier when we study curves. Lalo na yung may mga circular curves na graph. Yun lamang po. Thank you very much. Jayan, okay na ata tayo?
And so that was a very comprehensive discussion, Professor Passion. Ayan, so tama no sa ating mga participants, napaka-comprehensive. Okay, so doon sa mga hindi nag-react, may mga katanungan siguro tayo. So kindly put your questions in the chat and then please include your name and your affiliation or sorry, institution. Ayan. Okay, so meron po ata tayong tanong from Jim B. Sadol. Okay, what are some real-world application of polar coordinates po? Thank you.
All right, so thank you very much for that question. We use polar coordinates most of the time if we study circular motions. For example, circular motions include planetary orbits. So actually, itong polar coordinate system na imbento ito to derive the planetary motion yung kay Kepler, Johannes Kepler. So kung matatandaan nyo, ginamit niya itong polar coordinate system to study planetary motions, and napakaganda ng result niya dahil dito. Okay? So real world examples, if you see a curve, any circular motion, magagamit natin ang polar coordinate system. Okay? Hindi lang real world application. Pwede mo rin itong magamit sa mga kung ano-ano, because kanina nakapag-drawing nga tayo ng heart, di ba? Using polar coordinates. Tas ang dali pa nating na drawing. Okay? Sana po nasagot ko. Real world applications, anything involving circular motions na nakikita nyo in real life, skating rink, okay, magagamit po natin ang polar coordinate system.
Ayan, thank you, sir. By the way, yung mga nanonood po sa ating YouTube live stream, you can also put your questions in the live chat. So, yung mga may tanong po, you can pa-state na lang po yung question nyo sa chat box natin. Or if you want to use your mic, kindly raise your hand muna bago tayo mag-salita. Ayan.
I think okay na, Jayan.
Okay,
so that our participants can also have a short break siguro.
Ayan. Sige po. Ayan, so thank you everyone for attending our first lecture this afternoon for the second day of 26th SINSM. Ayan. So before you have your break and siguro mag-leave, kindly fill out the evaluation form. Okay. That is in the chat box. Ayan po. Okay. So as part of evaluating the Track A Lecture 4 session of Professor Anthony M. Passion during the 26th Summer Institute in the Natural Science and Mathematics, kindly accomplish the evaluation form by accessing the provided link. And so the evaluation form will serve as your attendance. Please be reminded that to receive a certificate, you must have at least 75% attendance in this 3-day event. Ayan. So thank you. And then, okay, so wait lang po. You can also access the evaluation form through this QR code. Okay. And so bago po tayo mag-leave. Okay, so if you done with the evaluation form, okay, pwede pong pa-request na mag-open ng webcam yung ating mga participants to have our photo op. And bago po tayo mag-break, sana. Okay. Ay, hindi na yung isang tao. Okay, ayan. Sige po, at the count of, wait lang. Okay, at the count of 3, ayan. 1, 2, 3. Okay. So, bali 6 lahat ng windows dito, no? 1, 2, 3. And 1, 2, 3. 1, 2, 3. And last. 1, 2, 3. Ayan, so salamat po. Huwag niyo pong kalimutang mag-fill out ng evaluation form. And then, meron po tayong last na lecture for today. Okay, so this will be at, anong oras na yun? 2:45. Okay, ayan po.
Hello, sir.
Hello.
Sir, introduce
Dinig
ko
ba
lang
ako?
kayo. Apo, sir. Apo, sir.
Okay,
Sige,
good.
introduce ko lang kayo, sir.
Sige lang. Thank you.
Okay. So, magandang hapon po ulit sa lahat. So, medyo maiksi ang ating break. So, let's proceed po dun sa last lecture natin. So, our last lecture for today, for this afternoon, so narinig niyo na. So, he's a professor of mathematics of the Department of Mathematics and Computer Science. So, konting background. He graduated BS Mathematics in UP Baguio and finished his MS Mathematics in UP Diliman. So he obtained his doctorate degree in math education, specializing in ethnomathematics last 2010 in Auckland, New Zealand. His researches include ethnomathematics and culturally relevant math education in the Philippines and indigenous concepts and values on sustainability, among others. Our speaker for today is also the regional coordinator of the International Network of Ethnomathematics in Asia, a fellow of the 2019 Australian Executive Leadership Program, and a recipient of the 2019 Endeavor Executive Leadership Program Award. So without further ado, let us all welcome Professor William Alangki.
Thank you, Joy. I think you need to make me a co-host. Co-host na ba ako? Ayun, okay, co-host na ako.
Ay, okay. Okay, sir.
Sige, naka-on na yung video ko. Can you actually see me? Because I don't see myself. Nakikita niyo po ba ako? Ayun, okay. Okay, sige. So yan, nakikita ko na. Okay, let me first share my... Sige. Okay. So magandang hapon. Thank you ulit, Joy, for that introduction. So ako po si Willie, teacher ako dito sa UP Baguio. And my topic for today's afternoon is on limits and continuity. So welcome to our SINSM and welcome to the second day of our lectures in math, especially in track A. I understand this is the seventh lecture, no, under this track. So I'm grateful that you are here with us today, despite what's happening around us. Naisip ko nga yung aking title. I played around with the words. Limits and continuity lang talaga siya, kasi it's a topic in calculus, no. It's an important topic, no, when we discuss as a prerequisite to differentiation and integration. Pero yun nga, ang title ko is Pushing Limits and Ensuring Continuity. Pushing limits because despite the health crisis that we are experiencing, we are still here trying to yun nga, push the limits of knowledge, no. While being cognizant of our limitations then, especially in terms of our physical and mental health, no. So despite what's going on, we want to push the limit of our students in their learning, push our capability in our teaching, but aware that our priority is really our physical and mental health, especially in the current context. And ganun din yan, yung we ensure continuity, no. Although it's not normal, we are not under normal conditions, pero somehow we try to ensure na continuing pa rin ang ating learning. So that's how I played around with the concept of limits and continuity. But of course, you know that medyo mathematical, no, yung ibig sabihin ng ating topic ngayong hapon na to, yung usapin ng limits and continuity. Okay, So quick check lang po. Can you understand me or can you hear me clearly? And do you actually see my slide?
Yes, sir.
Okay.
Ako, sir, nakikita ko.
So at clear naman, naririnig mo naman ako, Joy, na maayos.
Yes, sir. Yes, sir.
Sige. Okay. So before we go through the 3 objectives, can I request everyone, titignan ko lang kung gagana to. Can you please copy this link, go to this link, and we're doing a quick survey, no, sa Google form. So I'll give you a few minutes to please respond to this survey that I did, just so I have an idea of who are with us today. So I'll give you a few minutes po. So it's https yan bit.ly/3EP capital L 9F capital K. Kung pwede pong paki-reply yung ating survey.
Tinype ko po dun sa chat. Bakit pwede niyo po i-click yung link?
Okay. Thank you, Joy. Okay, we have 4750 responses so far. May 82 tayo dito. Sige, maghintay pa tayo ng a few more minutes. $50. Anong nakikita nyo, Joy? Nakashare pa rin ako, no?
Sir, yes, sir.
So ano nakikita nyo?
Yung sa, ano nyo, sir, sa Google Forms, yung,
yung
statistics, yung
yung-
yung pie chart, sir.
Okay. So yung 63%, Joy, ano yun?
Sir? Yung all of the above, sir.
Ha?
Yung all of the above.
All of the above.
So marami
Okay.
naman.
So, yeah.
Lahat naman.
Oo. Tapos yung 7.4, yung none of
None
the
of the
above.
above, sir. Yes, sir.
55. Sige. Okay. So mukhang more or less siguro we'll take this as yung total number of respondents natin para we can proceed. So this is a good profile, no? Pero syempre meron pa ring, alam nyo, colorblind kasi ako kaya hindi ko ma-distinguish yung between A, E, and F. So yung limits only, meron bang limits only, Joy? Itong 12.3 ba yan?
Yes, sir. Yung 12.3 yung limits only.
Limits
Tapos, sir,
only.
itong maliit, sir, na ano, nasa gitna, yung
B.
letter B. Yes, sir.
differentiation, no?
Basically, sir, naka ano siya clockwise. A to, tapos B, C, D, E, F.
Okay. So 12.3 is limits only. So may nagturo sa atin ng limits lang.
Yes,
Tapos
sir.
hindi na siya umabot sa differentiation. So this is a bit din ano yung differentiation only. This tells us na hindi kayo nag-limits. So kung dumiretso lang sa differentiation, ibig sabihin siguro yung formula yung
Yes, sir. More
diniscuss,
likely.
no? Oo. 10.5 naman, so nag-limits and then nag-differentiation. So we're assuming na ginamit yung definition ng limits o yung ginamit yung limits doon sa definition ng differentiation. And then
Yes, sir.
differentiation and integration only, ibig sabihin nun, hindi nag-limits. So baka nga yung formula lang din.
Formula lang, sir.
Then all of the above, okay, lahat naman diniscuss. And then yung F, yung none of the above. So may malit na porsyento. There's a small percentage among us na haven't really taught all these topics. Sige. So let me go. Thank you for responding to the survey. So because of that, yung number one objective natin for this input or discussion or sharing is to review the basic concepts of limits and continuity. Since majority have already discussed this, so majority is teaching naman these topics. So yun nga siguro review, and even for those who have not been teaching this, I'm sure you've taken this naman in your undergrad. So essentially review pa rin ang mangyayari sa atin. And then for 2 and 3, this is where yung majority of us, and even for those who have taught na some of the topics, this is where siguro we can discuss and contribute, no, or share our experiences. Kasi since we've been teaching naman na these topics before, perhaps we can identify some issues in our that pertain to the understanding of limits and continuity, no, that our students face. So baka siyempre mamimit lang natin the objectives na to if you're able to share your experiences on this, no? And then perhaps together we can suggest ideas on how to improve the teaching of these topics, especially if we want to meet the issues that we have identified in relation to the understanding of limits and continuity. Okay. Pero for most of you, baka walk in the park na nga lang itong topic na to, and talaga essentially review na lang ang gagawin natin, no? And baka nga mas marami pa kayong ideas in relation to how to teach these topics. So what I did was to look at the curriculum of K to 12, since sabi nga yung objective nga kasi nung itong SINSM natin is for our senior high school teachers, no? So para grounded tayo on the reality, on what you're doing essentially. So I looked at the curriculum, and I saw na yung basic calculus is a grade 11 course. It's offered during the second semester, and yung number of hours niya per sem for this topic is 8 hours per semester. And the prerequisite is pre-calculus. So that's the reason why dito sa track na to naunang diniscuss ang pre-cal. Now, in relation to limits and continuity na topic in your curriculum, the content standards want our learners to be able to demonstrate an understanding of the basic concepts of limits and continuity of a function. And yung performance standards naman, if you notice, basically we want them to be able to formulate and solve accurately real-life problems involving continuity of function. So kung performance standards, di ba ito yung testing, no? This is how we want to see whether they were able to achieve na yung content standards. Medyo strange lang na continuity of functions, hindi walang binanggit about solving problems on limits, pero dahil siguro nga ang continuity naman is defined using limits, no? Kaya siguro continuity na lang. Pero normally dito sa UP Baguio, for our non-BS math students, or even for our BS math students, marami pa ring pag nagpapa-exam kami, marami kaming questions on limits, hindi lang continuity. Kasi we want to know whether they've also really understood the concept of limits and they're able to apply it. No? So basically, ang performance standards namin will cover both limits and continuity of functions. Okay. And then I looked at the learning competencies. There are actually, for under limits and continuity, there are 17. No? Yung isa, may 7 pertaining to continuity at may 6 on limits. So what I'm planning to do this afternoon is to basically anchor my sharing or input according to these learning competencies. So sinundan ko itong ating learning competencies, and I prepared something just to illustrate or to illuminate these learning competencies. And yun nga yung gusto ko sana mangyari along the way. If there's some of you who want to share something in relation to a particular topic, no, na dito hirap ang estudyante dito, hindi nila maintindihan to, and ganito yung ginagawa ko ngayon. So maganda yon, makakatulong sa ating lahat na nandito ngayon. Okay. So these are going back to the learning competencies. So 1 to 6 nga. So yung una, yung illustrate the limit of a function using a table of values and the graph of the function, tapos distinguish between yung limit of the function as x approaches c and the value of the function at c, no? Kasi minsan may confusion talaga din dyan ng mga estudyante natin. And then you have the limit laws. Siguro dito hindi na tayo masyadong magtatagal dito. Sa 3 and 4, I'm sure this is quite parang kwento, no? Technical naman to at madaling ituro sa mga bata itong part na to. And then sa 5 and 6, we will rely on tables of values and graphs of functions. But actually, hindi masyado sa tables, mas sa graphs ang titignan natin ngayong hapon. Okay. Now, for continuity naman, learning competencies on continuity. So we'll try to cover all of this and present some ideas on each of these learning competency. Okay. Sige, so I hope clear yung gagawin natin. So basically, ang discussion natin will revolve around the learning competencies. No, we will follow this as our outline. So let's start. Also, dito sa UP Baguio, when we discuss learning limits and continuity, normally dinidevote ko na days dito, 3 to 4 meetings and parang 1 hour per meeting. So parang 4 hours. 2 meetings for limits and 2 meetings for continuity. So siguro we will not be able to really go deeper into all the important concerns that we need to discuss under limits and continuity in this lecture kasi nga 1.5 hours lang tayo. Okay. Kasi kung gusto natin talagang palalimin, kailangan natin ng mas mahabang oras for this. Sige. Okay. So of course, when we talk about when we discuss limit of a function, normally ginagawa ko motivation muna, no? Ano ba yung pwede ko i-provide na real life examples so that I can motivate the discussion, no? So yung when you search the internet, ang normally lumalabas yan, yung halimbawa yung ice cube in a glass of warm water. Pag nilagay mo yung ice cube dyan sa warm water and you monitor the temperature through time, eventually mag-stabilize na siya doon sa room temperature na kung saan nakastore yung glass. Okay? So in a sense, yung room temperature yung limit nung temperature, no, na which started from very cold with the ice cube in the glass of water, and then eventually na it approaches the room temperature. So in a sense, that's the limit, no? Of course, yung favorite example dito would be yung speed mo when you're driving. Sinasabi natin sa mga bata, sino ba nagda-drive dito? Medyo kwan lang ito, no? Yung uh, favorable ito doon sa mga marunong mag-drive or yung may kotse. Maybe this is not a very good example. Pero anyway, so we asked them, ano ba yung nakikita nyo doon sa speedometer, no? So sabi nila, yan yung speed mo at that particular time. So in fact, eventually, when you discuss differentiation, you will tell them na yung speed na yan is your velocity at that given time and it's given by the limit, no? By a limit. And later on, sinasabi ko sa kanila na itong limit na to importante kasi this is how it allows us to define what we mean by the derivative and integral. So essentially, sabihin natin sa kanila yung derivative and differentiation and integration, which are important processes in calculus, are defined using limits. That's why it's important for us to understand what we mean by the limit of a function. Ano ba yung intuitive idea? So, merong konting motivation and then we talk about the idea, no, intuitively. So this one is from Stewart. I noticed that doon sa inyong curriculum, minention nilang Stewart as one of the references. And also, Lighthold, itong T7. And interesting din yan kasi actually dito sa university, ito na yung references din natin. So if these are the books that you're using, the assumption is that when they come to the university, medyo familiar na rin sila dito sa mga textbooks na to. So anyway, for the intuitive idea of a limit, so suppose we're given a function f of x, which is defined when x is near it's near the number a, okay? So ibig sabihin nito, around a, the function f is defined, no? Around a meaning it's defined on some open interval that will contain a. But we are not requiring that the function is itself defined at a, no? It's possible na within an interval containing a, define yung function natin, pero at that point a itself, the function does not exist. That's okay when we talk about limits. So we have this notation. You are familiar with this for sure. We read this as the limit of the function f of x is equal to L as x approaches a. Okay? So parang basically ang ginagawa natin dito, at we are interested in finding out ano ba yung behavior ng function, no, ng f of x. Anong nangyayari sa f of x as we let our x approach the value a. Okay? And ang sabi dito, okay, ang nangyayari sa kanya, sa function natin, it approaches L as x approaches a. So itong L na to, this becomes the limit of the function as x approaches a. What does that mean? No? It means that yung f of x natin, we can make the values of f of x very close to L, as close as we want, no? By restricting x to values that are sufficiently close to a on either side of a. Okay? Possibly, but not equal to a. So, importante itong distinction na to, no? Hindi natin kailangan na yung, kasi notice x approaches a. So, we just want x to be sufficiently close to a from either side, no? Hindi tayo interesado doon sa instance na x is equal to a. So as we let x approach a, we want to look at the behavior of the function, what's happening to it. Pag sinabi natin na the limit of f of x is L as x approaches a, then that's the behavior of the function. Yung function natin approaches that particular number L as we also approach, as we let our x approach a. Siguro mag-shift lang ako sandali dito sa PowerPoint. Okay. So let's say we have this function given by this graph, no, of so a function y equal to f of x. And we are, let's say, andito yung ating, yung a. Sandali lang ha, hindi masyadong maganda yung aking. So ang gusto nating mangyari dito, we will let x approach a either from this side or from that side. So the assumption is that yung kung so we are given a particular interval, okay? At sa particular interval na yon ay defined ang function natin. So notice that our function f of x has the function has values within this interval, no? Except possibility A. So in-entertain natin yung possibility na yung function natin ay hindi defined sa A. That's a possibility. Okay. So ang nangyayari, we say that our function, the limit of the function as x approaches A is equal to L if we can let, so kung nandito yung ating f of x natin within this interval, okay, we can let f of x approach L, no, sufficiently close, no matter how close, okay, and you should be able to find and your x should also be sufficiently close to your a. Okay, so yun yung parang nangyayari dito if we say that the limit of the function the limit of the function f of x is equal to L as x approaches a. Now there is a more technical definition, no, involving epsilon delta for the limit of a function, pero I'm guessing na hindi yun itinuturo sa high school, not yet. Kaya ito yung dinidevelop dito na pag-explain ng limit ay intuitive, no? Intuitive idea. Parang yun nga lang, yung parang we let f of x be close to L by restricting x to a, close to a. Meron na ba ditong nagturo ng limit using epsilon delta sa high school? Anyone? Itinuturo ba ang epsilon delta sa high school? Yung epsilon delta na definition ng limit. Pwede ba ako magtawag? Daisy Ann Disu. Si Daisy Ann. It's a familiar name. Daisy Ann, nandiyan ka ba? Daisy Ann. Naku, wala si Daisy. Anyone? Si Edward. Sir Edward Albay. May sound ho ba kayo? Naku, nagkakahiyaan yata. So anyway, I'm assuming that we don't use the epsilon delta definition of a limit, no, when we teach it in high school. So parang intuitive, and that's probably the reason why doon sa learning competence, yung first learning competency, ito nga, we basically just illustrate the idea using table of values and the graph of a function. Okay. So,
sir, merong sumagot sa chat na meron naman daw nagturo. Pero meron, sir, na hindi din daw. Meron naman, sir. Kasi hindi daw po sense.
Kaya nga, yung sinasabi dito, is it necessary po na ituro? Yun nga eh, that's probably the reason why dito sa learning competencies natin, hindi naman binabanggit yung epsilon delta, no? Kasi nga, it's a difficult concept, no, for our students to grasp siguro. Even nga yung mga university students natin, minsan hirap din sa concept na yan. Okay. Intuitive definition ng limit ang ginagamit. Sige. Thank you for sharing. Okay, let's move on. So again, remember when we talk about the limit, we are interested, no, in the on the behavior of the function near the point A as we let x approach A. So some classic examples, siguro ito rin ang mga ginagamit nyo when you discuss this in your classes. So halimbawa ito, no, very simple function, f of x equal to x plus 1, no, linear function. Pwede nating tignan yung let's say gusto natin investigate ang behavior ng function near 1, near the point 1, okay? So halimbawa yan. Okay, that's basically the graph of our linear function na x plus 1. So ang ginagawa natin dito, if you want to find the limit of x plus 1 as x approaches 1, the idea is kung table of values ang gagamitin natin, so andito yung 1. Ang idea, we let x assume values of 1 that are less than 1, di ba? From here. Tapos yung iba naman greater than 1. Kaya tayo nagkakaroon ng table of values, no? So mamaya to. I-hide muna natin ito. Or dito na lang. Okay. So paano ba yung idea ng table of values yan for those who have not taught this topic yet, no? Paano ang ginagawa natin? So ang magandang exercise din ito for the students, ano? Kasi very visual, makikita nila ano bang nangyayari talaga din doon sa function when you let x approach 1. Okay? So, halimbawa, yan yung interesado tayo sa number na yan, di ba? Yan yung ating A. Okay. So, una, we can let x assume values that are less than 1 muna. So, maybe we can have -2. Then we get closer, di ba? Kasi we want x to approach 1. So, we get closer to 1. So, negative 1.5. Then, negative 1.1. Negative 1.01 maybe. So ito pwede natin ipagawa sa mga bata to.
Sir, malayo.
Wait.
Positive 1, sir, yung ano.
Ay, ano nangyari dyan?
Sir, positive 1 yung A.
Andali ah. Wait. Ay. Mali.
Oh, sir, pwedeng 0 mag-start. Pwedeng 0
Oo
yung...
nga. Sige, mag-zero start tayo dito. Layo masyado. Okay.
Sir.
Pala, nasa 1 pala ako. Wala pala ako sa 0. So,
sir.
okay.
Yes, sir.
0 tayo mag-start. Okay. Tapos 0.5.
Yes, sir.
Tapos point, let's say, tama ba, Joy?
Palaki, sir, palaki. Dapat 0.9, sir, tapos 0.999. Yan, sir.
Ganyan, di ba?
Yes, sir. Kahit wala na, sir, yung 0.05.
O kahit wala na to siguro pala. Point. O nga pala, bakit lumate siya? 0.9. Parang ganyan. So, we're telling our students, consider values that are a little bit less than 1, no? Getting closer to 1. So, ito yung mga values na yon from 0 to 0.9999. Tapos dito naman, values that are greater than 1. So, parang ganyan. lumilit ba to o lumalaki? We start with 2 plus 1.5. Ayan, 1. Palit siya ng paliit. Dapat ganyan. Okay. Parang ganyan yung idea, yung pag sa table of values. No? What we're doing here is we are trying to approach, we're letting x approach 1. Okay, for values that are less than 1, ito, and values that are greater than 1. Okay, so close enough to 1, but it doesn't have, x doesn't have to have that value 1. No? It doesn't have to assume that value. So, ang nangyayari dito, anong nangyayari sa function natin? So basically, the L2 plus 1. So pwede nyo silang pagawin ng ganitong table of values. Ganyan. So dito, makikita natin na as x approaches 1, pwede nilang hulaan kung saan lumalapit yung function natin. No? It looks like as x approaches 1, yung f of x natin gets close to 2. Kaya because of this, we say that the limit of our of x plus 1 is equal to 2 as x approaches 1. Yan. So yan yung at you can play around with different functions. No, you can ask your students. Sige, pwede rin itong same function na to, but what happens to the function when x approaches another number? Let's say 3. Ano naman kaya ang mangyayari sa behavior ng function natin as x approaches 3? So pwede silang gumawa ulit ng table of values. Consider values of 3 that values of x that are less than 3, but they get closer to 3, and then also values of x that are greater than 3. Okay? And they get close to 3. At mapapansin natin doon na yung value ng function natin will get close to 4. Yan. So yun yung idea nung examining, no, or determining the limit of a function using table of values. Now, kung papansinin natin dito, so okay yan, ano, yung simple function na yan na x equals f of x is equal to x plus 1. But what about this function? No? Dito, yung domain natin dito is R. So wala tayong problem sa value ng x. X can take on anything. But for the second function, f of x, which is x squared minus 1 over x minus 1, so if we medyo nadidelay yung ating pen, sorry. Dali lang. Notice that immediately dito, yung domain natin, it's the entire R minus our minus 1, no? So wala talagang value ang function natin at x equal to 1. But you notice, if we factor this out, this is basically just yung linear function na to, na kung tutuusin, parang ganito rin siya, no? Ang mangyayari nga lang dito ngayon, kung ito yung 1, hindi kasama sa domain ang 1. So talagang dito sa part na to, may butas dyan, no? Walang value ang ating function when x is equal to 1. Yan. Butas yan, no? There's a hole there. But still, that doesn't stop us from determining the behavior of the function. So this is our y equal to x squared minus 1 over x minus 1, which is also actually equal to x plus 1, no? Where x is not equal to 1. That's not, it's not in the domain. Okay. Yeah, that's right. So, kung kanina, walang problema yung function natin na x plus 1, domain niya R, it's defined everywhere. Dito ngayon, yung function natin is not defined at x equal to 1. But still, we can let x approach 1 by considering values, no, of x that are less than 1, as well as values of x that are less than 2. In fact, pwede natin gamitin yung same table kanina dun sa ating Excel. Saan na siya? Wait lang. Pwede natin gamitin tong same table na to, and basically ganyan pa rin naman ang makukuha natin. Kasi nga yung equation naman natin, yung function natin is just x plus 1, except that 1 is no longer part of the domain. So wala yan, no? Kasi the function is not defined when x is equal to 1. But notice that as you let x approach 1, yung function natin will still approach 2. Okay? At makikita rin natin yan sa graph mismo, no? Na habang pinapalapit natin ang values ng x natin sa 1 from the left or from the right, okay? From the left meaning values of 1 that are less than 1, dito naman from the right, values of 1 that are values of x that are greater than 1, mapapansin nyo na yung value ng function natin ay lumalapit din sa 2. Okay? So even if the function is not defined at x equal to 1, we can still say the limit of the function x squared minus 1, x minus 1, as x approaches 1, exists and is equal to 2. So, kaya natin binibigay itong ganitong klaseng example sa students minsan ay para makita nila na hindi kailangan defined talaga yung function at that particular point that you're interested in, no? Doon sa A, hindi niya kailangan defined doon. Again, yung una kanina, yung function na x plus 1, defined as x approaches 1, okay yan, no? Yung function natin approaches 2. Approaches 2. Okay? Dito sa example na to, defined yung function natin at x equal to 1. Okay, dito. Pero dito sa second example natin, ganun pa rin, the limit of the function is 2, no? The function approaches 2 as x approaches 1, even if the function is not defined at 1, at x equal to 1. Okay. Clear naman siguro yun, no? And then, may isa pa akong example dito. Yung number 3. So, in this function, so it's a meron tayong conditions, no? So the function is defined as x plus 1 whenever x is not equal to 1. However, when x is equal to 1, the function is 3. So yung domain pa rin naman natin dito is R, the entire R. Except that pagdating mo sa value na 1, hindi mo susundin yan, no? Yung formula na yan, kundi ang value niya ay 3. So ang nangyayari doon sa ating pag i-graph na naman natin siya, see if I can erase this. Ang nangyayari sa third function natin at x equal to 1, hindi 2. So kwanto, no? May hole dito. May hole. But in fact, yung value ng function ay 3. Ayan. So ito yung graph nung third na function na kino-consider natin ngayon. Okay, if I'm going to write it here, it's x plus 1, provided x is not equal to 1, and 3 when x is equal to 1. Okay, and the graph looks something like this. So again, if you're interested on the behavior of the function, what happens to f of x as x approaches 1? Kung yun pa rin ang interest natin, ganun pa rin naman makukuha natin, no? Based on the table of values, mag-approach pa rin naman ito sa 2. So, bakit maganda itong example na to? Doon sa first 2 examples kanina, dito, the behavior of the function as x approaches 1 is equal to 2. No? The limit of the function as x approaches 1 is equal to 2, which happens to be the value of the function at x equal to 1 as well. No? Kasi pag sinubstitute mo yung 1 dito, 2 rin makuha natin. Sa number 3, ganun pa rin. No? The value of the limit of the function as x approaches 1 is 2 pa rin. Except that in this function, walang value ang the function does not exist at x equal to 1. Okay? So hindi defined yung function natin when x is equal to 1. Dito sa una, defined yung function and the value of the function is 2, which is equal to the limit of the function. Dito sa second, hindi nag-exist yung value ng function at 1. Dito sa number 3, the limit is again 2, no? 2 pa rin naman kasi kung titingnan natin sa table nga of graphs, as you consider values of x that are less than 1 and greater than 1, pero close to 1, yung function natin will approach 2. However, the functional value of the value of the function now at x equal to 1 is 3. So, kung ito sana ang defining equation niya, di 2 pa rin sana ang value ng function, no? When x is equal to 1, similar to the number 1. Pero hindi eh. Kasi when x is equal to 1, 3 na siya. So this is an instance where the limit of the function as x approaches 1 is different from the value of the function when x is equal to 1. Okay, yun naman ang kaibahan nito sa number 1. Dito, nag-coincide yung value ng function saka yung limit ng function as x approaches 1. Dito, hindi nag-coincide. Okay. But both limit exist. So, sometimes, very purposive, no, yung pagbigay natin ng ganitong examples sa mga students natin, so that they will see yung differences, no, and the possibilities. What are the possibilities that can happen when we are considering limits of functions? Okay. Do you have questions so far? Familiar pa rin? For those who haven't taught the topic yet, baka may gustong clarification. Although I'm sure you've also discussed this in your undergrad, no? So parang we're just trying to remember what we've learned before. Sige. Ayan, may chat si Daisy Ann kanina. Sa college, sinuturo yung epsilon delta. Okay. As we suspected. Sige. So, yun yung ano nga ba yung learning competency number 2? Balikan nga natin yan. Kasi LOs 1 and 2. Okay. So ito yung pag-distinguish, no, ng importante yung na ma-realize ng students natin. Okay? Na iba ang importante maintindihan nila, no, yung kaibahan nitong dalawang ng concepts na to. Dito, let's say nag-exist yung limit L, yung binanggit natin kanina. It's possible that this limit exists even if the function is not defined there, or even if the function is the value of the function is not equal to L, no? As x approaches A. Ito yung value of the function at x equal to A. Ito, behavior ito ng function, no? As x approaches A. So, importante na distinction yan. It can happen that eventually, makikita natin to, or nakita natin, may isang example na tayo, it can happen na yung limit ng function na to as x approaches A, it can happen na pareho lang yan. Okay. Saan natin nakita yan? Dun sa function na x plus 1. Okay. So notice that we said that the limit in this example, we said that the limit of x plus 1 is equal to 2 as x approaches 1. But this is also equal to the value of the function at 1, which is also equal to 2. Okay. Dun sa second na, sorry. Dun sa second example natin, okay, which is also x plus 1. Again, the limit, so sinasummarize ko lang yung examples natin kanina, as x approaches 1 is equal to 2. F at 1 does not exist or is not defined. Okay, or not defined. Dun sa third example natin, the limit of the functions is still equal to 2. But this is not equal to the value of the function at 1, which in this case is 3. So sometimes we really parang paulit-ulit natin in-explain to sa students, no, for them to realize the difference of these two concepts, no, yung limit of the function saka yung value of the function. Okay. Now, for learning competencies 3 and 4, so ito lang naman yung limit laws na tinatawag natin, and these laws allow us to compute the limits more easily, no? If you're given different types of functions. Siyempre, lahat ng ito, dahil laws sila or theorem sila, may proof yung mga yan. And normally, we prove them using the epsilon delta. But in high school, we don't do that anymore, no? So I don't know, maybe, I think, I'm guessing na ipipresent na lang ito sa kanila as formulas, quote-unquote. So yan, yung una, yung limit of a linear function. M and B are constants. M is the slope, and B is the intercept, y-intercept. And how do you get the limit of a linear function? Di ganun lang. Mangyari dyan, MA plus B lang. So essentially, sinusubstitute mo lang yung A sa X. Pero ang idea dito, parang yung sa X plus 1 kanina, if you're letting X approach A, so you're considering values that are less than A, and considering values that are greater than A but close enough to A, ito yung makuha mo, MA plus B. So meron din tayong for constant functions, the limit of a constant as x approaches A is the constant itself. Okay? Parang kumbaga kung lang to, result lang ito ng linear function kasi when m is 0, so basically you get just this constant. And then the identity function x, limit of the identity function as x approaches A is A. Okay, that's easy to see. And then ang maganda dito, if you're given several functions, it's also easy to just compute for the limit, no, of if you're getting the sum or the difference of two functions, ganun lang naman pala, no? If you're given that the limit of the first function as x approaches A is L, and the limit of the second function as x approaches A is M, then if you want to get the limit of the sum, pinag-combine mo yung f of x at g of x, syempre, you want to look at the behavior of the sum around the same point, no? Yung A. Kasi alam mo na yung behavior ng f of x around A is equal to L. Ganun din sa function ng g of x. A din around A, M naman. So if you want to look at the behavior of the sum, it turns out na L plus M lang yun. Sum of the limits lang. Same thing with the difference, no? If you want to get the difference of f of x and gx and look at the behavior of the difference around x around A, then that's just L minus M. So in effect, kinukompute mo lang yung sum and difference ng mga limits na. That's assuming na nahanap mo na yung limit ng f of x saka g of x as x approaches A. And you can easily generalize this to sum and difference of n functions. So let's say if you have n functions f1 to fn, tapos yung behavior ng mga yan, bawat isa as x approaches A ay L1, L2 up to Ln, no? Then the limit of the sum of all these functions will just be the sum of the limits. L1, L2 plus hanggang Ln. Ganun din yung difference. If you're getting the difference, ganun din. So napapadali, no, yung pag-compute natin nung mga functions that are becoming more complicated in a way, no? Kasi hindi na lang isa, kundi you're getting the sum of two, okay, or the difference of two, or the sum of several, or difference of several. So ito pwedeng plus or minus na combination na yan, ano? Hindi naman kailangan puro difference yan. Pwedeng f1 plus f2 minus f3 minus f4, and so on and so forth. Okay, all the possibilities. For the limit of the product of two functions, kasi it's possible din naman na you're given two functions and you want to get the product of those two. Now you also want to get to look at the behavior of the product as x around A, no, as x approaches A. So if you can determine the limit of the first function as x approaches A, and you're able to show na L siya, and then yung second function, you're able to show na it's M, then yung limit pala ng product is just the product of the respective limits, Lm. And then again, you can generalize. So I don't know yung extent ng kung generalize nyo ba ito sa high school. Siguro pwedeng extend until 3, 4 functions. But I'm sure there are students who can appreciate the idea that you're getting the sum of n functions, you're getting the product of n functions. And when you're talking about the limit, so ganyan lang pala pang-compute yan. So hindi na natin siguro illustrate itong mga to, no? Okay. Continuing limit loss. So it's also possible for us to easily determine the limit of the nth power of a function. So let's say you're interested in this, no? You're given a function and you're raising it to n. Ano kayang behavior ng function na yan as x approaches A? Now, if you can, if you're able to show the limit of the function as x approaches A muna, and you're able to show na L siya, and n is of course a positive integer dito. So, anong mangyayari pag ni-raise ko to sa n? Well, yung behavior niya is just like raising the limit L to n as well. So, imagine you, for example, yung x plus 1 kanina, as x approaches 1, di 2 nga yung limit natin kanina, no? Pero let's say x plus 1 raised to 3 na yung gagawin natin. So x plus 1 raised to 3, then that's basically just 2 raised to 3, and that's 8. Okay, ganun yung parang application ng nth power. It's also possible to get the limit of the quotient of two functions. So ano yung quotient na yan? F of x over g of x. Okay, so how do we want to understand the behavior of this quotient as x approaches a? So if you're able to get the limit of the function f as x approaches a, and you're able to show na L siya, and then yung limit naman ng g of x as x approaches a is m, then yung limit pala ng quotient is just L over m. Provided, of course, that m is not equal to 0. Diba? Kasi, of course, you know the reason why. Why is that? So ganyan. Okay? And then, kung may nth power, may nth root then of a function. So n is a positive integer, and you know that the limit of f of x is L as x approaches a, then it's possible to get the limit of the nth root of f of x. And that's just the nth root of L. So parang nangyayari dito, pwede kong i-evaluate ko muna yung limit ng f of x as x approaches a, saka kunin mo lang yung nth root. No? Of course, we know that that if n is even, dapat L is positive. Yung limit natin should be positive kasi otherwise, hindi na to defined. Okay. And then some particular parang ito particularity ito ng quotient. Okay? Tapos ito rin naman, ito ay ng number 3. Yan. So if a is any real number except 0, if you want to get the limit of 1 over x as x approaches a, that's just 1 over a. Again, a should not be 0. And dito, what about the nth root of x? What's the limit as x approaches a? That's just equal to the nth root of a. Again, provided that a is if n is positive integer, dapat a is positive, diba? Or pwede namang negative yung a as long as n is odd. So okay yan. So yun yung ito yung mga limit laws na I'm sure pag binibigyan natin sa mga students, nag-enjoy silang gamitin, no? Kasi it gives them a handle of a tool to immediately compute for limits of functions, and it gives them a handle din of the concept. Parang mas naintindihan nila. So ang task talaga natin dito as teachers is to look for good examples na not too complicated, na mabubuwang sila, matutuliro sila, pero not too simplistic. Pero it's good to start with simple examples, and then yung degrees of difficulty, di ba, medyo i-improve natin. Pero wag naman tayo magbigay ng masyadong komplikado at convoluted na ng mga functions. Sometimes kasi imbis na makatulong, mas una-una nakaka-discourage. Minsan it also muddles the concept. So it's really important to strike a balance in looking at examples. Okay. Now, hindi na mention ito doon sa learning competencies nyo. I'm wondering why. Pero siguro, kung di man din discuss comprehensively or ng detalyado, baka nababanggit nyo pa rin yung one-sided limits, no? Kasi ang hirap iwasan Ang hirap hindi i-discuss yung idea ng one-sided limits. So ano ba yung one-sided limits? Ilang beses ko na rin binabanggit kanina, di ba, na if you're looking at the limit of a function as x approaches a, yung pag-consider natin ng values kanina, values that are less than a, and then values that are greater than a. In fact, yung values that are less than a, parang you're approaching a from the left. From the left meaning the values that you're considering for x are smaller than a. Ang notation natin ganyan, no? May negative sign. Tapos pwede rin yung isang approach naman kanina from the right, we're looking at values of x that are greater than a naman, but close enough to a. So may ganung notation tayo. So when you look at the limit, so it's possible to get the limit of a function as x approaches a from the right, meaning consider mo lang ay mga values ng a that are ng x that are less than a. Pwede 'yon at pwedeng may limit siya doon. Okay? So the limit of f of x is equal to L as x approaches A from the left is if L, if we can make the values of f of x arbitrarily close to L. So mapapalapit mo yung values ng function natin sa L by restricting x sufficiently close to A with values of x that are less than A. Okay. Similarly, you can talk about the limit of the function as x approaches A from the right naman, from the right. And that's equal to L, no? Pwedeng L pa rin siya, which means that we can make the values of f of x close enough to L by taking x that are sufficiently close to A, but these values of x should be greater than A. Yeah. So let's look at some examples. Joy, anong oras na? May enough time pa naman, ano?
Medyo sir, mga 25 minutes. Ay,
25
hanggang
minutes.
ano ba tayo? Mga 30 minutes, sir.
Okay, good. Sige. Sige. So let's look at, let's illustrate this, no, itong ideas na to. Ay. Hirap ng maliit ang screen. So yung isa, y is equal to x minus 4 yata to. Yeah, okay. So, may tanong pala, may tanong ba at this point? Do you have any clarification? For those who haven't taught calculus yet, so siguro this is a a good parang review na rin for all of you, and yun, it will give us some confidence siguro to say na pwede ko na ituro yan. Sige. None pa naman daw so far. Thank you. Sige. Okay, so siguro magandang makita niyo yung graph nito, although you are familiar with this. Madali lang naman siyang i-graph. Sige, graph na nga lang natin. Muna. We are done with this one. Okay. So parang pag ganyan yung graph natin, no? For square root of x minus 4. So notice that yung domain natin dito consists of all lit ng space ko. X element of R such that, sorry, delayed ang ating pen, such that X is greater than or equal to 4. Okay? Kaya naman, ito lang yung mga values ng X, di ba? Na part ng domain. So, dito sa set na to, that's basically 4 up to positive infinity. That's your domain. Your function is defined, no, dito sa domain na to. Now, you might want to consider, or you might be interested in understanding ano bang behavior ng function ko near 4, kasi ito yung 4, no? So if you ask that question, ang tinatanong mo basically, what is the limit of the function x minus 4 as x approaches 4? Okay, now this is where we have to be very careful, no? Notice that yun nga, again, yung domain natin is from positive 4 to infinity, no? So you cannot talk about x up, kasi yung idea kanina ng limit na x approaches a, sabi natin let's consider values of a that are less than a. So from the left yon, and values of a that are greater than a. So from the right. Kung ito yung function na tinitingnan natin, it doesn't make sense to talk about, to consider values of x that are less than 4, yung mga nanditong x, no? Hindi mo pwedeng i-approach ang x from the left. Kasi in the first place, your function is not defined in that region or in that interval. It only makes sense to talk about approaching 4 from the right, no? By considering values of x's that are close to 4 but greater than 4. Ito lang ang meaningful na approach. Therefore, dito, hindi pwedeng ganyan lang yung limit natin. We need to say that we are approaching 4 from the right. So we are looking at the values of x's natin that are close to 4 but greater than 4. And ang kagandahan dito sa one-sided limits, lahat ng limit laws natin kanina ay applicable din sa one-sided limit. So in other words, ito parang nth root lang ito. We know that we can basically parang do it this way, no? Pwedeng ipasok natin yung limit sa loob as x approaches 4 from the right, and notice that this will just be equal to 4 minus 4 or 0 pa rin. And that's what you will get, no? If you get if you substitute values of x that are less than greater than 4, close to 4, eventually itong value na to will approach 0. Okay? Kaya ganun yung solution natin diyan. Okay? So talagang minsan hindi natin may iwasan, depende sa functions na kino-consider natin, na i-approach lang yung value na a of, on one side, no, either from the left or from the right. In certain cases, pwede nating i-approach from both sides, no? Parang yung example natin kanina, nakita natin yon. Pero it's also possible na yun nga hindi. So ito naman binaliktad ko lang just to illustrate din. So yung from the left, wait. Nasaan yung PowerPoint? Ayan. So yung isang example naman natin, 4 minus x naman siya. Ano ba yung graph naman yan? Okay? So dapat itong 4 minus x natin should be greater than or equal to 0 kasi square root siya, no? So this should be positive. So 4 is greater than, or ang domain natin is minus infinity to 4. So kung for greater x is less than, okay, 4, 0. When x is 0, meron tayong 2. So parang ganyan naman yung graph natin. Nagka-curve siya, syempre. So in this example naman, if you want to look at the behavior of the function as x approaches 4, hindi pwedeng x approaches 4 lang, kundi as x approaches 4 from the left naman. Dito mo lang siya pwedeng i-approach. Okay? Kasi dito lang may value yung function natin. Itong mga values dito, beyond 4, hindi kasama. So, this is the meaningful limit, no? Yung itong part na to. You can only approach 4 from the left. So, you consider values of 4 that are less than 4 but close to 4. Yeah. So, depende sa function na kinikonsider natin, it's possible that we can only approach a particular number either from the left or from the right. And those are our one-sided limits. Okay. What about number 3? 2 plus x minus 1. So ang idea, bigyan natin ng variety of examples, no, yung mga estudyante natin. Examples that will help clarify the concepts. And examples that they are familiar with. So halimbawa dito, we're assuming na alam na nila yung absolute value function, no? So how do we simplify this function? We know that x minus 1 is equal to x minus 1 if x minus 1 is na-delay ang ating pen. Wait lang. So para ma-analyze natin to properly, let's try to come up with a simpler formulation muna. So here, dapat dahan-dahan ang pagsusulat para hindi mahuli. Okay. So, ito alam ng mga students natin yan, no? And this basically, ay, mali, may kulang ako. Bakit ganun? Ganyan yan ang mangyayari. So therefore, pag yung function natin will now become 2 plus x minus 1 if x is greater than or equal to 1, and 2 minus x plus 1 if x is less than 1. Or tama ba? 3 plus x, 3 minus x. Okay. So, itong original function natin dito, we can rewrite it in this manner. Okay, so mukhang interesting na point yung x equals 1, ano? Ano kayang behavior ng function natin as we approach 1, no? From the left and from the right. Notice that when x is less than 1, so we're looking at values of x that are less than 1, ang defining equation natin ay 3 minus x. Pero when we are looking at values that are greater than or equal to 1, the defining equation is x plus 1. So, kung ang interest natin ay tingnan yung behavior ng function limit of 2 plus okay. So we're interested in looking at the behavior of the function 2 plus absolute value of x minus 1 as x approaches 1. Di parang nangyayari dito, dalawang limits to. Limit of, kasi yung equation natin ay, yung function natin ay x plus 1 if x is greater than or equal to 1. So parang mangyayari, x plus 1 as x approaches 1 from the right for this part. Di ba? And yung second part kasi for x less than 1, so limit, ang defining equation natin ay 3 minus x, so of 3 minus x as x approaches 1 from the left. So, ito yung example where kung may bibigyan natin yung ganitong example sa students, makikita nila na from the original function na given, kailangan mo palang mag-ingat, no? Especially if you're interested in on the behavior of the function near 1, na near 1 ay ganito pala yung mangyayari. Why is that? Because of yung ganitong condition. Okay? Or yung ganitong particularity ng function na kinonsider. Okay? So, ito, makuha natin, parang sabi nga, you can easily apply the limit law. So, this is just equal to 2. And ito naman, equal din sa 2. So, maganda rito, nag-coincide, okay, equal yung one-sided limits. Yung limit from the left is equal to the limit from the right. And they're both equal to 2. And in fact, that is one of the conditions for the limit of the function to exist, di ba? If you remember, sabi sa atin, the limit of the function exists and is equal to L as x approaches A if both the left and right side limits exist as x approaches A and are also equal to L. So in this case, we can conclude that the limit of the function as x approaches 1 exists, okay, and is equal to 2. Again, minsan nakalimutan nating emphasize yung idea na existence, no? If it exists, kasi it's possible that the limit of the function does not exist as x approaches a particular number. Okay, so yeah, so yun yung parang minsan nakalimutan natin yun eh, no? But it's important to remind our students that from time to time that you can say, no, na you have to sometimes say that the limit of the function exists and it's actually equal to that particular value. Okay, kasi sometimes hindi nag-exist ang limits. Okay, so I hope na-clarify yung one-sided limits, especially with number 3. So dito, sa first example natin, you can only approach that the particular number na 4, no? Kasi 4 yung interest natin kanina, from the right, ito from the left. Tapos itong isa, approaching 1, both from the left and from the right. Another one lang, isa pang point siguro before we move on. Dito halimbawa. Kaya naman from the right lang kasi we're interested in the point 4. Pero kung ganito yung function natin, tapos gusto kong tingnan yung, halimbawa, dito yung 8, no? 8. Gusto kong tingnan yung behavior ng function as x approaches 8. I can approach 8 from the left and from the right, from both sides. Bakit? Kasi yung 8 naman, it's well within the domain, no? The function is defined within the interval that contains 8. Diba? Kung andito yung interval na yan, nandyan yung values ng function natin. So, kung ito yung interest ko, hindi ko interest ang 4, then if I look at the limit of the function as x approaches 8, I consider values of 8 that are less than 8, and values of x that are less than 8, and values of x that are greater than 8. So, both sides yung approach ko. Pero dito, kaya lang tayo limited sa from the right, kasi nga, hindi naman defined na yung function dito sa values that are less than 4. So, ganun lang yung baka kasi akala ng pag-isipin ng estudyante dahil ganito yung function natin, lahat na lang ng limits ang kukunin ko dito from the right na lang lahat ang approach ko. Hindi naman. Ito lang particular sa number 4 na yan kasi nga beyond this, no, less than 4 hindi nakasama sa domain. Ganun din sa isang example na to, no? If you want to get the behavior of the function for values na within itong interval na to, so from the left and from the right yan. Pero dito, kaya tayo from the left lang kasi nga beyond 4 hindi nakasama sa domain. Okay. So I hope that's clarified. Okay. So dito medyo ang sabi sa learning learning outcomes, gumamit lang ng table of values. So I'm assuming na Yun nga, may mga table of tayo dito, values natin ng exponential saka logarithmic functions. Balikan natin. Okay. Yung pag-apply din pala ng ayan no, yung limit of particular algebraic functions, so polynomial, rational, and radical. Medyo this will come from the yung limit laws, no? So i-apply nyo lang yung limit laws dyan. Kung rational siya, yung di ba yung f of x over g of x, ganyan. Tapos yung radical, yung nth root. Polynomial, magandang behavior ng polynomial natin. So defined naman siya in its entire domain, so you can easily get the limit of polynomial as x approaches any value. Ngayon dito sa 5 and 6, sabi, compute the limits of exponential, logarithmic, and trigo functions using tables of values and graphs of the functions. And then there are particular, dito sa number 6 na learning competency, na-identify nila yung 3 particular functions, no, that are of interest. Tingnan yung limits ng mga functions na to. Sin t over t, 1 minus cosine t over t, tapos yung e to the t minus 1 over t. Bakit kaya? Kasi itong mga to ay magiging useful later dun sa later discussions, no, sa continuity and even in the differentiation and integration. Kaya gusto nilang medyo ma-introduce na sila dito. Kahit pa nga table of values lang ang tinitingnan. Okay, now, so let's look at exponential, logarithmic, and trig. So hindi na natin yan masyadong i-detalye kasi familiar naman tayo basically, no, sa exponential, logarithmic, and trig. It's really more of how to present this. Nakatulong talaga pag may graph, especially when you're dealing with these functions. Okay. Now, I don't know if you're familiar with autograph. Ito halimbawa. Yan, you can download this for free. You can use this to help you teach, no, yung calculus na hindi lang limits and continuity pati differentiation and integration. Meron ding GeoGebra. Baka mga ginagamit nyo na yan no? May graphing calculator. Baka mas marunong pa kayo sa amin. Ito hindi ko ang nasa akin ay autograph. Hindi ko rin siya masyadong na-maximize. Nagagamit ko lang siya to graph basically. Graph functions. And I noticed that our students are able to appreciate the discussion more if you also show them graphs, no? So may tables ka, may graphs ka, meron pang analytic na discussion. So yung various representation would help our students grasp the concepts that you are discussing. So ipakita ko lang itong autograph for those who are interested. Saan na siya? Wait lang.
Sir, singit lang po ako saglit, sir.
Sige lang.
Naka-post na po ulit yung link ng evaluation form po doon sa chat. Paki-check na lang po. Thank you. Kasi may mga sir, may mga nagsasabi na alis na gano'n.
Okay, sige. Bakit ayaw yung sandali lang ha. Ayan. For those who are interested sa autograph, you might want to look at this. Advanced. Ayan. Medyo mabagal. You should check for updates. Okay. So, ito.
Freeware yan, sir. Freeware.
Free, oh.
Freeware.
So, freeware. Okay. So, halimbawa, if you want to enter an equation, so yung kung exponential yan, di ba? Nagsisimula naman tayo sa familiar na exponential function. oops, equals. And then so ito yung basic na exponential function natin. And then pag may graph kang ganyan, and you want to look at the behavior of the function near a point, di pwede nyo namang tignan na lang using the graph. So halimbawa, you want to get the limit of the function e to the x as x approaches 1. So ito yung tinitignan natin na point. Dito. So you can let x approach 1 from the left and 1 from the approach 1 from the right. And titignan mo kung, di ba? So ito yung, so you can approximate the value of the limit. Kasi as you approach 1 from the left, lumalapit tayo dito sa L na yan. Kung ano man yung L na yan, ito. Diba? And then as you approach x from the right, ito naman yung value ng function natin. Okay. So hindi natin masyadong didetalye to. And then you can play around with your exponential functions. If you want, you can enter another function and let's say yan. So ito naman, another exponential function yan. Again, if you're interested on the behavior of that new function at near a point, then maybe you can use the graph for the students to approximate the limit of that function near the point. Now, dito clearly as yung behavior ng function natin nung dalawa as x approaches 0, may kita niyo na yun yung parang lumilitaw na limit, no? If you approach 0 from the left or from the right. So limit seems to be 1. Ayan. Now, depende sa exponential function na titingnan natin. Kung logarithmic function din, pwede rin gamitin to. Okay? Pero tingnan natin lang siguro yung, let's say, equation. Okay, yung ln natin, which is the inverse of exponential function. Again, now, this is interesting din pala, yung ln x. Kasi notice that if you're interested in looking at the behavior of the function near 0, unang-una, you cannot approach 0 from the left, di ba? Kasi alam natin na yung ln x hindi kasama sa domain niya yung 0 at yung negative values, no? So you're interested in as x approaches 0, no? Anong behavior ng function natin? So you can only approach x from the right. From this approach lang. Saan ba yung pen natin? From here lang yung approach natin. Di ba? Kasi dyan lang naman define yung function. And notice nyo siguro pag papakompute yung mga bata. Sige nga, let's start with 1. Okay, di yan na makuha nyo, no? 1/2. By the way, ayun, yung ating function. So, what about 1/2? Anong value ng function? What about if you get closer to 0, no? Makuha, pag gamitin niyo sila ng calculator, notice na makuha nila palit na values, no? Negative values. And somehow these values will get close to wala siya, palaki siya na palit, no? So dito pwedeng introduction ito nung infinite limit, but I don't think you are also discussing infinite limits na sa high school students. So pero this could be an introduction already. Okay. Ngayon ito rin pwede yung gamitin for trigonometric functions na, no? You can play around with different trig functions. Syempre yung pinakasimple, mga y cosine, diba? Yan. then you can play around with this already. And again, you can ask the student kung ano yung behavior ng sign at a particular near a point. Then they can probably look at this graph and try to estimate, or they can compute, no, using may calculator din dito. Yeah. So if you want them to look at the behavior of the function near zero, then pwede kang mag-calculate ng sine of, let's say, 0.5. Yan, 4794, ganyan. Kung 0.5, so itong 0.5 na to, yan. Tapos you can get closer to 0 pa. You can consider values that are closer to 0 from the left or from the right. Of course, makikita nyo na lumalapit sa 0 yung values. Yun yung limit natin. So, yan, pwede nyo nang paglaruan yan, pati, let's say, if you want tangent. Okay. So, you can see na within a particular interval, di ba? Siguro ito, yan, within ito. So doon, pwedeng yung tignan yung behavior ng function natin within that interval. Kasi at certain points, undefined yung ating tangent. Okay. So yung graph can help students understand yung limit of functions at a particular point. Okay. So let's continue. Nasaan yung aking... So wala pa tayo sa continuity. Ito pala. Ito, yung tatlong ito. Sin t over t, 1 minus cosine t over t. So again, may ginawa akong Excel file kanina. Para lang makita niyo na kaagad. So ito yung sin x over x. We know that that the function is not defined when x is equal to 0. So all you can do is to approach that value, no? So we consider values of x that are less than 0 and values of x that are greater than 0. And it looks like ang nangyayari sa function natin, it will approach 1. Diba? Ito, papalapit siya sa 1. Yan. So yun yung behavior ng function natin around 0. Okay? Isa naman yung 1 minus cosine x over x. Ito, palapit ito sa, again, the function is not defined as 0, pero yung value ng function, yung limit niya exists and it's equal to 0. So all these three functions, in fact, undefined sa x equal to 0, but all their limits exist as x approaches 0. Okay. So itong isa, itong exponential function na to, 1 naman yung limit. So pwede nyo na naman silang i-graph, no? Just to verify kung tama nga yung nakuha natin. So ito yung isa kanina. And sorry. Yan ang itsura ng sin x over x. So ito parang siyang may value at x equal to 0, di ba? Pero actually undefined siya dyan. Except that, yung limit kasi ng function approaches 1. Okay? So if you continue this, so yung value ng function gets close to 1 as your x's get close to 0. But notice that the function is not defined at x equal to 0. Okay. So yung ganun din yung isa kanina. y equal to 1 minus cosine x, cosine x over x. Anong color ba yan? So as x approaches 0, sabi natin 0 yung mukhang 0 yung makuha, no? And the graph confirms that. But then again, x is, the function is not defined at x equal to 0, except that yung limit niya nag-exist doon. Kaya parang ganyan, parang continuous yung graph, ano? Pero yan kasi, yung limit niya will approach 0. Okay. And then finally, let's get a new one. Yung exponential kanina, sabi natin as x approaches 0, 1 yata yung 1 yung nakita nating limit. So e to the x minus 1 yata yun over x. Ayan, tama nga. Ayan, yung e to the x minus, oops, sorry. Mali. Mali tayo. Sorry. Paano ba yan? Dapat pinapaliit ko. Wait. Nagkagulo na. Pero anyway, yung kanina yung original na equation natin, as x approaches 0, the value of the function seems to approach 1. Even though the function does not exist there. So ito yung para ma-appreciate siguro ng mga bata yung functions yan kasi in-identify sa learning competency, no, na tignan yung particular na functions na to. So you can do you can ask them to get a table. So pwede sa Excel, sa makikita nila na yung isa approaches 1, isa approaches 0, yung isa approaches 1. Then the graph can also help. It will help them see na ganyan ngayon nangyayari dun sa functions. Okay. Sige. Maghabol tayo. So tapos na yung sa limits. Dun naman sa continuity. Hindi pa ba ako nag-overtime? Hanggang 4:45 na? Nag-overtime na?
Overtime na, sir.
Overtime na. Sige. So
Yes,
yung continuity is, quick na lang ito. Continuity is a parang an important consequence, no, of yung sa limits kasi this is an important ano ba to? Parang feature na gusto natin sa mga functions natin na sana continuous sila. And basically ito yung condition natin for it to be a continuous function, no? Yung limit of the function as x approaches a exist at dapat equal siya sa value ng function. Kaya naman binilabor ito kanina na point, no? Kaya ito isang learning competency sa limits kanina kasi pag na-satisfy itong condition na to, continuous yung function natin. And if any of these conditions is not satisfied, then discontinuous yung function natin at A. Okay. So, wala na tayong time, but I can give you later itong mga slides na to. Basically naman, standard yung mga definitions. Yung marami dito galing kay Stewart at kay isa, si Lighthold. Pero yung mga examples, pwede nyo pag-aralan on your own yung mga examples. Tapos yan nga, may mga types of discontinuities. Meron yung removable. Bakit removable? Kasi you can redefine you can remove the discontinuity by redefining the value of the function. Meron yung essential discontinuities na wala ka na magagawa. Okay? Tapos meron ding mga infinite or asymptotic discontinuities. Importante yung discontinuity kasi lalo dito sa applications niya, no, yung intermediate value theorem, intermediate zero theorem, but most especially sa extreme value theorem na madidiscuss nyo later sa differentiation. Yung optimization to no, na sabi dito, in a closed interval, sigurado tayo na may absolute maximum and absolute minimum on that closed interval for as long as your function is continuous. Kaya mahalaga talaga maintindihan ng mga bata kung ano yung konsepto ng continuity kasi magagamit nila ito later. At ito yung isa sa pinaka-importanting application ng calculus, optimization problems. Okay, I think I'll end here. Now I understand why ang nilagay lang nila ng secretariat na title ko ay limits, hindi kasamang continuity kasi nga talagang kulang ang oras natin. As I mentioned earlier, doon sa aming syllabus dito, we discussed limits and continuity in 4 meetings, no? Halos 4 hours. So it's quite difficult really to cover everything. So I hope may na-trigger ng konti sa memory at nakatulong yung pag-identify ng ilang mga important points, no, to remind our students when they're looking at limits, especially limits kasi yun na-discuss natin. And yung paggamit ng multiple representations, no, yung graphs, table of values, nakakatulong yon sa appreciation ng mga bata. So try to integrate the different types of representations, multiple representations for you to for them to understand the concepts that we are teaching. So hanggang doon na lang muna. Maraming salamat. I don't know if we still have time for some questions. Pero ewan ko, Joy, pwede pa ba? Wala pa namang 5. Kung may tanong.
Yes, sir. Wait lang, sir. Tanong ko, sir, yung mga kasama ko.
Merong nasa chat. Give us a copy of your PowerPoint.
Yes, sir.
Autograph 5 for Mac does not support. Okay. Or later. May mga problema sa ano?
I think i-collect naman, sir, nung mga secretariat yung PowerPoints, no? Tapos mukhang bibigyan naman yung mga participants.
Unless may burning question dyan. Pero thank you for attending this lesson.
Thank you, sir. Maraming salamat po. Sige po, kung meron po kayong mga pahabol na tanong, pwede nyo pong i-open po natin ng floor for questions.
yung discussion dito, ikonto parang take off point to for yung next topic nyo bukas, yung derivatives sa integration. So, kung may ilang questions pa, pwede rin tanungin si April bukas. Pero makikita nyo bukas kung paano i-apply ang limits doon sa definition ng derivatives. So, yeah. So, maraming salamat ulit, no?
Yes, sir.
See you tomorrow. Thank you,
sir,
Joy.
Thank you, sir. Maraming salamat po ulit.
Ano ba to? Stop share ko na?
Siguro, sir. Sir.
Stop share na. Sige, thank you.
Hindi ko alam kung ano yung sa certificate.
Ayan, good afternoon po sa lahat. Ayan, thank you, sir, sa very nice and detailed presentation. Ayun po, so yung evaluation link, posted na po siya sa ating Zoom chat box. So paki-fill out na lang po para makakuha tayo ng certificate. And then, you can also access the Google Form link through this QR code. Ayan po. Ano po ba?
Tapos po, announcement. Sa MSP po, yung deadline po ng MSP membership ay before May 15, 2021 for the annual MSP convention. Sige po. Wala na. JN, wala na.
Ayun po. So, ayun. May continuity pa rin naman po yung lecture natin bukas. Ayan. So, we will have our third day or our last day of SINSM. And so, sana po maka-attend pa rin tayong lahat. Yun lang po. Hindi.